honor and privilege to welcome you. Thank you so much for accepting the invitation. And now I would like to hand over the session to Dr. Prashant Pawar, sir. Over to you, sir.
Can you see my shared screen is visible or not? Yes.
Okay, so you are sharing your PPT here.
Screen I'm sharing.
Sir, you can share now.
Okay. Is it visible? My screen is visible?
Not yet, sir. It will.
It is showing. I will try again. Somehow it is not visible. I don't know. Screen. Is it visible?
Sir, your screen is not visible.
Let me check once again. I'll stop and log in again. जुना असल्यामुळे होतंय का? To share only meeting organizers and presenters. Hello. Hello. Hello.
Sir. Are you sharing your screen?
Yes, but it is now not.
You have to press share button and you have to share your window or
it is showing,
whole screen.
It is showing that only meeting organizers and present. Can you give me authority to share?
Actually, I have given, but I'll still check, sir.
It is showing only meeting organizers and present.
Sir, I've changed now.
Yes. Let me check. Now it will come entire screen. Share. Is it visible?
Yes, it is visible now, sir. It's clearly visible now. Yeah.
Thank you. Yeah. We are good to go. Let me quickly jump. Sorry
yes,
for
sir.
the
Yes, sir.
Almost we lost 20 minutes, but I will try to cover up. Thank you for inviting me. I hope I am audible, loud and clear, and my screen is visible, and my handsome face is also visible. So, topic I have chosen for the this FDP is water management and disaster management using drone. As you might have seen in the presentation that in my introduction, I have a big project of drone ecosystem development, and that's why we have been exploring from last 2 years various applications of drone. And one of the application we have been looking, though we have not got result related to this, but we have been exploring. And in this presentation, I will be kind of presenting a literature available on water management and disaster management using the drone. And you can see the in this presentation mainly what we will be doing is we will be utilizing the drone photogrammetry images which are required for the knowledge development related to this water management, etc. So before we go to exact problem, let me quickly walk you through the basics of drones and photogrammetry related aspects. So if you see what are the different components required, so drone is formed by frame. There are different types of frames, and there are to these frames various BLDC motors are connected based on whether it is quadcopter or hexacopter or octocopter. And then for these BLDC motors, again propellers are connected, and these propellers could be of a different configuration and size as per your lift requirement and various maneuver requirements. And you can see these are the things, and these are being controlled by your electronic speed controllers, and there are different flight controllers. If you search about, then you can do different operations and controls through that. So this is one of the typical controller that the most famous one, where we can connect different components of drone. And of course for power purpose we need a battery, and then radio transmission for the control receiver, and then GPS for locating it, and then camera, gimbal, especially in this photography purposes. If you have other activities like spraying, noise, and then different sensors and activities will be different. And then sometimes there will be onboard computers also. The next part which I will cover is the kind of basics of photogrammetry, which will create a foundations for us to understand how the drone technology, especially image based aspects of drone technology, can be utilized for the your water management related issues and disaster management related issues. And this science is basically referred as a photogrammetry. So if you see the definition, it is like photogrammetry is a science of obtaining reliable information about the properties of surface and objects without physical contact with the object, and of measuring, interpreting this information. So first we have to gather the data in the form of photography, and this photography this photographic sensor may be of different types. We'll see in next few slides. So purpose is like gathering the data and generating the information. So this is the part here. And then what are the like useful information generated through these photographs generated? You can see these are called as orthomosaic, 3D models, and others. So this will whatever the slide by slide photographs we will be taking through the drones, which will be converted into kind of orthomosaic, 3D models, and others for us to understand in the as per the required manner. So what are these 3D models? These 3D models help us when we have to do the volumetric computations, like kind of either if you see in from civil engineering perspective, you can see from the if you have to find out the volume of excavation, or in this case we have to find out the volume of water bodies, and likewise. And then is typical model as we understand as a civil engineer is digital elevation model, or we call it as a DAME. And then like we can use NDVI, vegetation map, thermal maps. These are the different data we produce. So you can see the typical pictures will come something like this. And then you can see there are different types of photographies. One of that is like a drone photography. It could be space photography, aerial photography. It could be fixed wing aircraft photography also. You can do the manual photography also. And as we discussed, like one of the image type is NDVI. Then like these are the information we collect through this photography. One is geometric information, next one is physical information, the third could be semantic information and temporal information. Let's understand whatever data we get or what type of data we need through drones, that we have to plan accordingly. Your sensors will change, or in short, what kind of camera is to be utilized, it will change. For example, geometric information involves the spatial position. So in short, your longitude and latitude and the shape of the object, and it is most important information source of the photogrammetry. And then physical information refers to kind of energy generated, wavelength and polarization, etc. And in the semantic information, what does these images mean? Means what you can tell is you are linking the photographs with the ground reality. It is called as a ground reality, or you can also call in the image processing language as a annotation. So we are when a computer has to automatically do it, so initially you will have to mark it manually, or uh, through some other softwares, etc. And that's what is. And then after training the computer, then it will start throwing out the semantic information. The next one is temporal information, is related to change of an object in a time, usually obtained by comparing several images which were recorded in different time. Means what land usage change took place. So you have to understand there is a something called as a spatio-temporal information. Spatio refers to the XYZ, or you can say longitudinal, latitude and azimuth. Okay. And then temporal refers to the time. So these are the some of the outcomes which will come after the your photography and after doing lot of processing. And then you can see these are the some of the installation of sensors. Some are the RGBs, some are the NDVI camera, and this is how we have to do the flight planning. So usually we decide the terrain, and we decide the amount of, typically there is a called as, you can see here, it is called as a forward overlapping and side-wide overlapping, and typically it covers more than 60% overlapping is required, otherwise stitching of images will not take place. And you can see in this part the individual images obtained and they gets overlapped, and these each, apart from these photographs, each images are tagged with longitude and latitude, and that's how they there are softwares for the processing, and then the final stitched images we will get. And this gives us the correlation with the exact terrain on the ground. And if you want to do further processing, you can further crop it, but from these the images obtained by drone needs to be overlapped, and before getting the information or typical image processing, you need to stitch them together. And in this, these are further slide how you can do the planning, how much overlapping should be there, how this ground calculation, etc. is done. And as I told you, these are the sensor selection. So like how you can do the take photography, whether it is a perfectly perpendicular to ground or with some angle, etc. And then these are the some of the typical softwares available, like AGSoft, USA Master, and Pix 4D Mapper. Can I get some feedback whether I am audible, visible, etc.?
Sir, you are audible but not visible.
Not visible. Me or my screen?
Both are not visible.
You check. I have my
You are
own
visible. Sir, you are visible. Your PPT and also your user.
Yes, yes. Okay, okay, okay. You check
Okay.
yourself. Okay.
Okay, sir.
So
I'll leave
yes,
and I'll join again, sir.
yeah, yeah. I have kept my own feedback system also in my
Thank you,
lab.
sir. Thank you, sir.
So they are giving me feedback. I am visible and all. audible. Okay. So these are, like, as I told you, different softwares. I will skip this part. It is going in detail. So you can see the ground controls, which part you have to do photography, etc. We have to do marking. And then, as I told you, we have to collect the data, and on computer software, you can stitch them together. You can do the 3D modeling like this, mosaic modeling, etc. So this is what is a basics which I wanted to tell you. Now we will go ahead with the kind of how drones are important, and how what they do in the water management and disaster management, and what are the typical applications we solve. And I have taken further images. You can see these are the actual images taken in the Pune region by our water resource department for different purposes. And I just wanted to show what kind of applications they have seen, like unauthorized pipelines siphoned through the canal. This is done by one of the presentation photographs I have taken through the irrigation department drone application of government of Maharashtra. You can see they have identified unauthorized pumps in the canals. So this is also one of the application. Then unauthorized wells near the canal region, encroachment on the river part. They have identified where they have changed the course of river, and there they have planted some crops, etc. So the advantage of this drones is that it can give the GPS connected precise data, and with the advancement with AI integration, it makes our life easy. And it gives the processed data very fast, maybe tenfold, hundredfold, in a faster manner. And which is the time is essence in case of this water management maybe there, or disaster management maybe there, for the typical decision making applications. And then you have to compare this before advancement of drone. There was a quite good advancement of satellite images, and uh, as compared, both are good, but satellite, the advantage of satellite images is that it covers a large area, whereas these drones will cover little less area in a kind of typical time plus span. But the satellite images will give coarser information, whereas these drone images will give denser images, which will help us to do ground level planning or detailed planning. So let's understand what are the different water management applications that can be solved using drones. It may be like water body monitoring, managing irrigation, or predicting floods. So let's understand one by one. I have taken related papers also. We will take that example, and through that we will understand, so that we can you can take a help of your computer science, some drone members, and then you can think from civil department what problems can be solved. Let's understand monitoring of water resources. This is the journal paper I found when I searched. It was related to drone based imaging to assess the microbial water quality in an irrigation pond. So what they have done is they have installed the kind of various well-known sensors on the ground, and they have compared the imaging, whatever they have done, and the actual ground truth data, and they have tried to correlate with the dissolved oxygen, SPC, pH, etc. So that's how this is one of the example they have solved. Next example is about the irrigation management. And here you can see one example I have taken is surface flow measurement from the drone. This is a very important problem which helps us to take decision about creating the minimal impact that should take place, or in the what you call affected cities, or affected villages in the vicinity or on the bank of rivers. And that's where it is sometimes difficult to have so many physical water flow measurement devices, what we measure in CUSEC, etc. So instead of that, if we can use this drone technology for measuring the water flow. So here is the example. This is how they have done the experimental arrangement. So they have chosen the particular region, and they have marked the grid, and then accordingly they have done the photography, and in these grids how this water spreading took place, and based on that they have identified the kind of stream, and then the kind of speed in different streams of the river or water body. That's the thing it is possible to do. That's why intentionally I have taken the good research papers published related to this domain, and you can see the velocity measurement, mean velocity, and its standard deviation, and you can see uh, kind of measurement done through near accurate measurement done through flow meter, which was like about 2.54 meter per second. And whereas through drones they have done by two tracers they have passed. One is artificial tracer, and then the second one is through natural tracers. For your understanding, what is mean by tracers? Tracers are like some kind of color dye we start releasing in the water body, which will flow through that, and it becomes easy for us to get images, and through that we can get the speed of the velocity of the water, maximum velocity of the water. Next, this is also essential part in the water management and water body management, is like bringing the awareness about the quality of water. Usually whether initial water is safe to drink without, typically without even doing the process. And this may play big role if we bring the awareness through maybe weekly or monthly or 6 monthly photography of the region where tourists are coming, etc. The kind of, and the way we have seen the temporal data, that is over a period in January, or for example, if we take some seashores, recently I visited in Goa, so or maybe before Wari, I come from Pandharpur, so before Wari, how this bank of river Bhima, we do the photography during Wari or immediately after Wari or after 10 days. So likewise, and we are also, this is done through photography, but I guess we are also trying to do the sample collection at the different region. And I guess our team can look into the watercolor change, but the problem is that they send the different water. So if whatever at least stored water we can study. So here what they have done is drones for litter monitoring. Litter in the sense kachara monitoring on the coast of the coast and rivers. So you can see they have optimized the heights of photography. This is the essential part, at what height we should do the photography. If we take at a larger height or more height, can we close the noise? Okay, so if we do at higher height from the ground, then what will be there is you will not get the what do you call clarity of images. And if you bring your drone close to the ground, you will not able to cover the larger area. So you'll have to create the balance of that, and that's how they are for different water body and different regions. They have identified which distance will be good to cover the CM per pixel, and you can see the clarity of different cm per pixel. If you bring close to the ground, so it gives quite good images, and as you go away from the ground, the clarity we are losing. But if we use the computerized system, and if we can do this kind of semantic segmentation, we will able to isolate the areas in the first phase, at least the tentatively surface area covered by the liter we can judge. Even we can see whether if we give contract to someone about the cleaning contract, etc. These kind of one round will easily help us to understand. These are good problem to give for the electronic students to do. This in the first phase we don't need, you can solve it in a two class problem. One is as a whether it is a liter or not, okay, or ground, liter and ground. The next one, if you want to understand what are the typical liter, whether it is a plastic, whether in Pandharpur you may have like cloth also, then chappal and shoes and all those things are there. Typically now Mahakumbh Mela is there, so you can this kind of studies will bring awareness and we can understand. Next one is flood monitoring and prediction is important because as we are staying on the bank of Bhima River, this is very essential as we have Ujni Dam and the control of the water delivery to avoid. Can I request to mute?
देखो जो मेरे पास अभी है ना,
Hello.
मेरे पास जो अभी है हमारा
Hello.
का हितवा है.
Organizers, can you mute the person who is disturbing? So in flood monitoring,
आपका एग्जाम चालू हो गया कि कौन सा सब्जेक्ट है?
ऊपर इलेक्ट्रिक कुछ भी चूज कर सकते हैं. मैंने वो चूज किया है सोशियोलॉजी, साइकोलॉजी, इंडस्ट्रियल वर्क एथिक्स और प्रोफेशनल इलेक्टिव है.
organizers, I will not able to talk with someone else.
स्टार्ट हो
Manish
गया
Singh,
है,
you
क्लासेस
have
भी
to
जा
mute.
रहे हैं.
Is it possible disable mic?
कोई नहीं रही है क्लासेस को.
Second. Okay, I will continue. Sorry. This thing. Okay, so flood monitoring and prediction is very important. It helps in taking decision, especially in case of dams where controls are there. So there is a pre-prediction during flood and post. These are three stages where drones can be utilized. One is post-disaster. What do you call? What kind of damage it has done, that can also be identified. But for me, prediction is a very important problem. That's why in the interest of time, I have taken a publication which has been there about the water level detection in the flood. So what kind of water level is increased, that detection is important. Usually sometimes correct information we won't get. So if we can do the drone survey continuously, and once we get images, it has to be stitched, and within half an hour, within 30 minutes, within 15 minutes, whatever less now amount of time, can we deliver the kind of flood line at the current situation. And that's what can be done. So how we can do this is a typical process where you can see the one is online and another is offline. Offline is the process where we train the system. What we do is initially is we collect a lot of flood related images. Every time we keep on improving also, and the collected images are maybe for augmented, etc., maybe for increasing data, etc. And then we can use the deep learning algorithms in the and we may not get huge database, So you will have to use some kind of transfer learning with whatever limited data we have, and in that we can create the same model whatever we have developed of this CNN, or what you call in general you can say deep learning. You can have recursive CNN. Why recursive CNN is like as and when you will start getting the data, new data, you can keep on improving your trained model. Initially you can start with existing model, and then you can have the different things like object processing, filtering out how many houses, this can, and also floodline identification, and it helps us to take the decision. This is the first part is about training part, and this is actual utilization. Once we have a trained data, then we may get images directly pass on that, and we will start getting the level. So let's understand how it is done. Typically when we have the flood images, we will have to do supervised learning case. In that, what you'll have to do is you'll have to do masking like this. It is called as giving ground truth. And then once we have such ground truths available, you can see these are the boxing done for like building box, water level and all that. You'll have to mark which one is sand, which one is ground, which one is water. And then once the labeling is done, then we can get the kind of data augmentation, and then we can pass these images through the CNN algorithm whatever you will develop. And once you train that, automatically whatever feed you are getting through drone, it will get converted into with how many houses are submerged, and which are houses, which are cars, which are roads. That information classification, recognition of houses, etc., is possible. And even if you do the imaging through lower level, you can also identify human resources, animals, and things like that, which will help us in a rescue operation. Let's understand what are the different disasters. Here I am not giving the example because I just wanted to cover as many applications just to give glimpses. So what are the different disaster management applications that can be covered through the drone? One is emergency response coordination. It helps us. The very important aspect we have to understand about the drone technologies, it's a UAV, it's an unmanned air vehicle. So the places where we will not able to reach, or the manned vehicle or human being will not able to reach, or in the difficult terrain there are different kinds of drones can be sent, and the information can be collected. We can understand the stranded people, stranded animals, where we it will help us to coordinate. Like for example, the recent fire in what do you call Hollywood, Los Angeles, LA, and there also these drones will help us in giving the kind of hotspots available. Then we can utilize the post-disaster survey. This in typical in Maharashtra land survey, they call it as Anevari, I guess. So you have to understand. You typically our Talati is doing that job, but if we have a system of doing so, at our lab we are slowly working on this to understand the like post disaster manage assessment of we are focusing mainly on the crops because our is a agriculture research mandate. So here the post disaster assessment can be done in minimal area, and the relief funds can be uh, delivered to the those who are affected, really affected, and that's how it can be done. Next we spoke about the search and rescue operations can be done, live feeds can be given, and coordinated efforts can be done. Even in case of where there are no networks, etc. In such cases also swarm operations can be done, and this technology will become a boon. Further, we can also do like infrastructure monitoring in case of emergencies. So we can see how if there is a large evacuation is required, so we can see where we can migrate people in case of emergencies, not only related to water, some kind of gas leak or other threats, etc. So in that case, drones will become play a important role. So let's understand a few more case studies related to what we just discussed about. The first case study I'm taking again related to water body and about the water storage, especially farm related, or it is you can use this case study for the water conservation application. So it is like what Pani Foundation was doing, what kind of trenching can be done so that water conservation can be done. And this is a very nice publication I found that is related to agricultural water management. It is about the a method to estimate water storage of on-farm reservoirs. So OFR we will be saying again, that is on-farm reservoirs, by detecting slope gradient based on multi-spectral drone data. So there will be different images. One is RGB, another is multispectral, and third could be temperature hyperspectral, and fourth one is temperature based thermal imaging. Okay. So in this case they have used multispectral images, and if you can see what they have done is they have tried to clearly identify based on the whatever images they are getting as a two class problem. One is what you call ground and water body, and then they have prepared the used these Gaussian mixture model, and they have used, what they have done is they have used satellite images as well as multispectral images, and they have created a framework for quantifying the water storage on farm. And they have also tried to identify the depth of these farms. And this is how they have calculated the water surface area, and base, and this is the kind of formula for calculating the normalized difference water index. So they have identified through this multispectral which colors will play important and what will give us a differentiating factor for the ground and water. And you can see potential slope zones, and then ground and water, so that you can estimate in the region which is good with minimal excavation or minimum amount of trenching. You can collect the water at a certain level, and this is how you can get the gradient slopes, and then through that it becomes easy to identify the regions where water storage can be done. And you can see how they have calculated the slopes and depth, etc. And they have also even compared their results with the ground truth, and you can see the amount of accuracy achieved by their actual water storage and derived water storage level they have compared in the cubic meter. So next one example is in the recent 2020, when there was a hurricane at USA. They have extensively used the drone for the effective disaster response. So the disaster management team, they used to feed the different information about the flood affected region for assessment of for the taking the decision. And we can see from the whatever few examples I have taken, what we can learn or how we can go ahead is, first of all, you need to collect the data, which is very difficult because uh, uh, these disasters will come randomly. We have to wait for disaster, and that's why we will have to be always ready wherever drone setups are there. So whenever they get opportunity in such, and then there are difficulties also. We may not get the permission from the government agency to collect the data. So we will have to approach the agencies, those who are using the drones, and see if we can acquire. Unless until we have the data, we will not able to do that. So such application development is an important role. But especially like flooding and all those things can be easily done. The important problem is like collecting the data. So this and that's how over the period, maybe next 10 year, 15 year, we will have to collaborate with some agencies where resource, and that's what these people are giving the drone technology. Even softwares also available, but nowhere the complete solution is available, because it's a long process where huge amount of data has to be collected, and then algorithms, ground truths needs to be collected, and then it has to be trained. And by the time you do this, the technologies are changing, things are changing, and that's why sometimes it remains in the kind of research domain format only. As I told you, there are regulatory bodies and ethical considerations uh, where drone data obtaining becomes difficult. However, if we have a continuous system, it's a not only drone, but there are various technologies. As I told you, deep learning, AI, CNN, and then IoTs. IoTs can be installed for getting the ground truths, like some kind of water stations where actual water flow measurement and typical things, where IoTs will play very important role, where you don't have to go, you will keep on getting the data at actual data during the flood situation. And then why, then you may ask, like why drone imaging is mm, required, even though IoT may become very costly, because it will give point data at a different places. We need to install the same sensors, where drones can be used for the collecting huge data, and we don't know which place the disaster may come. So IoT installation becomes a very difficult in the situation of disaster, whereas drone deployment becomes very easy as compared to IoT. But in the combination, if we wisdom creation becomes easy, integration becomes easy, and these algorithms can be created, and such huge big data can be utilized to make a useful algorithms. I already discussed the challenges. I guess I'm done. In short span, I have covered a lot. So any questions? You may have a lot of questions. Hello.
Yes, sir, you are audible.
Yeah. My presentation is over now. If anyone has got any questions or anything you want me to add, we can discuss. So maybe briefly, I will tell you what we have a project, and so currently we have Government of Maharashtra 33.75 crore project. In that we have 2 to 3 tasks. So the first one is we have to establish a drone related training
Camera on करो
activity.
कि काही गरज नाहीये.
So
Yeah, thank
training-
you so much, Dr. Prashant, sir. It was
Okay.
wonderful session. So participant, do you have any question? Any question from participants? It was so simplified and you have so elaborately explained everything. There is no question. So thank you so much. A virtual round of applause for Dr. Prashant, sir.
Thank you.
Thank you, sir. Yeah, it was
Yes.
wonderful. Thank you.
Thank you.
Participant, be in this meeting. We are connecting with the next speaker. So we'll let you know immediately. Till that, be in the meeting only. Thank you. Yeah, participants, we have connected with the next speaker. He need another 10 minutes to be at his place and start the presentation. Till that, you may enjoy tea break or coffee break. We'll be back at around 3 o'clock and 10 minutes. Thank you. Yeah. Good afternoon, participants. Welcome back again. We have certain instructions to assure that you will get the certificate in time. So please note all these instructions clearly. As every one of you is aware that 80% of attendance is mandatory. So after starting of the third session, we are going to immediately upload the attendance. So if you have any query regarding the attendance, please make sure that you are informing all these queries to coordinator in between 4:45 p.m. to 5 p.m. So in that gap between second and third session, please convey in text format your all queries to our coordinator so that everyone who is sincerely attending it will be considered. So no query can be entertained after 5:15 because we have to upload the attendance at earliest. As you know that the certificate should be given to you at earliest. The second point, the quiz will be activated at 6:30 p.m. The duration of the quiz will be 6:30 to 7:30. Overall feedback of all sessions, that link will also be available on ATAL portal. So for quiz and the feedback, both these links will be available on ATAL portal in your login. You know that 80% of attendance is mandatory from all the sessions. You should have 70% score in the quiz. The quiz will be on 3rd of February, that is today, from 6:30 to 7:30. The feedback for each day to be completed by all participants. It is mandatory that each session's feedback you have already filled, except these two, which are pending now, which will be proposed. Except that, all feedbacks you have already given, already submitted it. This quiz will be conducted on content of online session conducted by the resource person. So till these, whichever sessions are over, from that resource person, we got the questionnaire, and based on that, the quiz will be there. Since all these sessions are conducted on Microsoft Team platform, session attendance is recorded automatically through Microsoft Team. Therefore, ensure you are logging through registered email address and are attending throughout the session. So still, if there is any query, feel free to reach out to our coordinator in between time 4:45 p.m. to 5 p.m. Once again, I will repeat. The attendance queries 4:45 to 5 p.m. Please convey it to our coordinator. Second important point, the quiz will be in between 6:30 to 7:30. The link will be available on your login of ATAL portal. And the third important thing, the overall feedback you have to fill up at earliest because before 24 hours we have to complete all feedback and all these documentation part so that the certificate can be given to you. That's all from our side. The next speaker is already onboarded. Let's start the formality of presentation uploading and all those things. And then we'll have a formal introduction as soon as sir will be able to start the presentation. Good afternoon, all. It is my privilege to introduce our esteemed speaker for today, Dr. Sheikh Babar Sir, a distinguished academician and researcher in the field of geology. He is currently serving as a principal at Jnanopasak Shikshan Mandal's College of Arts, Commerce and Science at Parbhani, and has been an integral part of Department of Geology throughout his career. With an impressive 36 years of teaching experience and 26 years of research expertise, Dr. Babar has made significant contribution to quaternary geology and geomorphology. He is recognized research guide at both Swami Ramananda Tirth Marathwada University, Nanded, and Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. Under his mentorship, 5 PhD scholars have successfully completed their research, and he continues to guide 4 more PhD students and 4 MPhil scholars. Dr. Babar's research output is remarkable, with 76 journal publications, 30 book chapters, and 45 conference proceedings. He has also authored 6 books, further cementing his authority in geological studies. His dedication to research and academia has earned him prestigious recognitions, including being named a Fellow of the Gondwana Geological Society, Nagpur, in 2017, and being featured in Marquess Who's Who in Asia. His vast experience combined with his passion for advancing geological research makes him an invaluable speaker for today's session. We are honored to have Dr. Sheikh Babar sir here. Sir, we would like to welcome on behalf of Bharati Vidyapeeth College of Engineering for Women, and we request you to share your expertise. Over to you, sir. Thank you.
Thank you. I'm audible now?
Yes, sir, you are audible.
Ma'am, actually, how do you share the screen? That's a problem with me.
Okay, sharing is a problem for you. Okay, sharing of presentation.
Sharing.
Yeah, sir, we are telling you. Yeah.
Sir, I have stopped sharing. You can put volume down of one of your device, so it
Okay.
will not echo.
I'm now visible over here.
Yes, you are visible, sir. Ha. Now, unmute one of, sir. Unmute one of device and other device will be on lower voice. And there is with camera mic, there is a share button. You have to share from that button.
Hello.
Yes, sir. You're audible now and it is not echoing. You can share your screen, sir.
That is
There
coming
is
there.
share tab. Yes, your voice is coming, sir.
Where is the share tab? No, but problem is that.
Sir, your one of device voice must be lower down, so it will be easy. I think camera one, you can lower down the voice.
Camera is coming, I think so.
Yes, camera is, you're visible, sir.
Okay.
Now
So
you have to click share button.
where is that share button?
Sir, share button is nearby mic button.
My. But it is not opening. What to do? Yes, share.
So you can share me your presentation. I will share it from here.
I will. Can I share it on WhatsApp or will it be possible to share?
Yes.
Is it coming?
Sir, on the top, are you able to see on the topmost side, right side? Leave button is there. Just adjacent to leave button, share button is there.
Yes, I am going for that.
Yeah.
Choose from window. Okay. Now I'm sharing.
Yes, sir. Yes, sir. Thank you.
Is it visible now?
Ah, it's
Yes, sir.
visible, sir.
Yes, sir. Yes.
Okay,
It's
okay, okay.
visible.
Okay.
Thank you. Thank you, sir. Yeah, over to you.
So I'm now continuing with the presentation for this FDP on application of remote sensing and GIS in disaster management and mitigation. There are certain aspects that can be covered in this. What is a disaster management? Phenomenon of natural disasters. Then we need a disaster management. These disaster mitigation methods are also there. How we can mitigate? We are concentrating on these aspects in consultation with the remote sensing and application of remote sensing and GIS in this particular disaster management. So what is a disaster management? Discipline dealing with the avoiding some risk. It is not possible to stop anything. These are the natural calamities. Not even big country like USA could stop the very, we can say, devastating fire. So we cannot stop, but we can try to avoid the risk. This involves the preparing, supporting, rebuilding society. The natural and man-made disasters are there. So all these we have to take into consideration while management. Continuous process by which all the individuals, groups, and communities manage hazards in effort to avoid the ameliorating impact on the disasters that has been done in that particular area, whatever it may be the area. For this, for early warning systems can be adopted. Foreseeing future disasters can also be done. Take the prevention methods on reliable information and to prohibit natural disaster occurrence sources. So we can try for that and then we can come out with certain conclusive proofs. Now, what are these phenomena which are called as a natural disasters? They are, we know, flood, fire, landslides, earthquakes, cyclones, droughts, volcanic eruptions, and even tsunami and epidemics. Many epidemics can also be the disasters which can be man-made or natural disasters, but we are more concentrating on the 8 that natural disasters are there. So here these floods are there, earthquakes are there, then the cyclones are there. Similarly, we can say the tsunamis. These are certain photographs that will be shown in this particular. And there is a particular level for these disasters to be understood and to be managed. National, regional, medium level, local level, even site investigation scale level, the different, we can say, remote sensing measures for these natural disasters can be there. Now here, this application of remote sensing, I will try to show in the possible way of the various different disaster management systems, like for wildfire, volcanic eruption, flooding, earthquake, drought, even tsunamis are there, landslides, and cyclones or hurricanes are there. Then we have other you can say disasters also possible there, and these other disasters are in the form of avalanches and diseases or epidemics that we have seen. Now, the number one is a wildfire. Fire detection by satellite provides a highly efficient means of detecting and eradicating the forest fire without a large number of ground-based workers. So that remote sensing definitely help here. And by knowing the facts and the ancient aspects, we can correlate them for understanding through the GIS, we can say softwares, and then we can try for the future prediction as well as for the management of these particular areas. These thermal infrared imageries show hotspots that may distinguish from clouds of a similar, albedo similar, we can say the transmissions of the, we can say the transverse or the reflections of the rays. Of fire detection and management system should have the following aims. That is, measure the geographical limits of a particular fire front, estimate the fire intensity, monitoring of the burnt areas to look for talent fires, mapping of the burnt areas, etc. should have been carried out. Some glimpses I will be showing over here. And these fire disasters, such as the wildfires, maybe natural causes are there, maybe the man-made causes are there. They have some high natural causes are generally actually we can see the lightning on the trees can catch the fire. Similarly, high atmospheric temperature and dryness, that is low humidity, also is responsible for such type of activities in many forest fires or wildfires, you can say. Another example of a Siberian wildfire, the western region around the Termen and Moss in early actually 2021, as per the Moscow time reported, 40 million acres of land have been burned down in the Siberia. These are various, we can say, the large devastating fire produced or fire forms in the world. These are certain examples which I have quoted over here. Let us have some list of these fires. About Siberia, as I was telling you, 55 million acres of land has been burned out in the Russia. The second is Australian bushfire. Third one is a great fire in 1919 in again Canada. Chinchilla fire at the Canada, and even the Black Dragon fire in 1987 caused the acre of 250,000, sorry, you can say 2.5 millions of the acre area, China and Russia. Like this, there are several different, and lastly, I have quoted the example of USA, about 40,500 acres of area has been burnt out in this fire. So these are certain examples how these fires can be detected or can be monitored through the different observatories from NASA or even the satellites which we have in our, we can say, Indian satellite also can detect these type of the fires that have been these are the hotspots which have been detected through the thermal infrared analysis of a particular hotspot anomaly in the world. Here is the example, just a recent, we can say, fire extinction that has taken fire. We can say it burst out or burnt out the whole, we can say, Los Angeles part, 10th January 2025. The Guardian is the source for this. So this was the before and this was the after. That means then and now, this type of situations, we can see how the devastating fire can be recorded through this remote sensing data. Another example of the same, that is January 8th, 2025, from the same area, how this fire burnt out the locality in this particular area. The next one, I'm now concentrating towards these flood aspects. So floods are easily seen from the space. particularly over very large areas. Sometimes a view of the ground can be obscured also because of the clouds. But okay, the flood can also be understood through the remote sensing that is needed to be managed. GIS models allow us to estimate the risk of flooding before it happens, monitoring by the different agencies in the world. This has the devastating disaster mitigation for Mozambique during 2001. Some photos are being shown later on. Like this, there are several flood events happened in the world which can be detected. Nobody can stop the flood or nobody can prevent that, but we can take care or we can prepare regarding these activities or these devastations or these disasters can happen. Flood disaster have in India also annual flood inundation is 40 million hectares. Bangladesh is also one of the most flood prone countries in the region, in the, you can say, peninsula, or rather we can say Indian subcontinent. Sri Lanka also, China, annual summer flood. Like this, there are several different floods that have occurred in the world, and even this year also, last year, 2024 also, this year also, Arabian desert, we can see that they have caused the flood. Desert Arabia also witnessed the Saudi Arabia, the UAE witnessed several large floods. The cars are floating and other things, that scenario we can understand. This is the example of a Mozambique river flood. Earlier, it was like this, and after this flood, how this. So in 1999, this was the situation of the same Mozambique area, but after the flood in 2000, first March 2000, how the situation has drastically changed. We can look at through this figure. These are the images from NASA. Another example here, the Bhubaneswar and Cuttack area witnessed the flooding area. Brown parts shows the brown areas shows the flooding parts in this particular region. Similarly, Mumbai also several times witnesses the flood. This was a high flood part that we can see here in this figure. Mumbai witnessed during 2005. So July 26, July 2005, this type of so 25 to 27th of July, this was the flood part in this Mumbai region, and therefore it has caused some drastic, we can say, the impacts on the livelihood as well as the wealth of the natural wealth, we can say. Another example, this is a Venice flood from the Spain. This has caused again a very large devastation. These type of floods can be monitored and can be mapped. Here are certain precipitation details are shown here. Precipitation accumulation of this in the 2024, a very harsh flood that witnessed the area. So this type of, you can say, the parts of the flood areas can be visible and can be carried out the researches in this aspect through GIS as well as remote sensing. Another example, satellite images of flood disasters with respect to result of the flood mapping method. Here are the top three, are the three different regions showing the flood through the, we can say, the remote sensing or satellite image, but below three, rather we can say lower three, are the maps that have been carried out, maps that have been flood mapping results are These three here, and the top three are the input from the images. This is the
Sir, we are able to see only your first slide.
I'm audible now.
Yes, sir, you are audible. The only thing is that we are able to see application of remote sensing and GIS in disaster management and mitigation. That slide only is visible to us. The slides are not changing.
Slides are not changing. Okay,
Yeah,
okay,
yeah,
okay.
yes.
So I will once again, number of slides I have shown actually. Oh, I will first of all stop sharing and then again share it.
Yes, sir. Yes,
Is it
sir.
okay?
Yes, sir. Absolutely okay.
Okay, just. Is it visible now?
Yes, sir. It is visible. You are seeing on the satellite images of flood disaster.
Yeah.
That we are able to see.
That is the
Okay.
slide I wanted to.
Yes, sir. Yeah, yeah.
Okay.
Over to you, sir.
Now the next one is the another disaster that is called cyclones, hurricanes, or typhoons. We can see many natural disasters result from extreme weather events such as hurricanes and the cyclones, etc. These are actually the meteorological phenomenon. Typically large scale and can be seen from the space also. That is a true aspect. Another thing is that these satellites allow us to track these phenomenon, determine the likelihood of them affecting the human population, and hence undertake the mitigation activities. For such we can say the disaster management, the remote sensing and GIS plays a very important role. Again, the role of remote sensing for support of geoengineering activities or mitigation as discussed by various different researchers. The same thing is here. The cyclones, now the slides are changing or not, ma'am? Hello?
So it is the same slide, satellite images of flood disasters with respective
The
results
slides
of the
are
flood
changing?
mapping method. No, it is not changing, sir.
The same slide is okay. But how it is possible? Slides are not changing. Okay, I will once again share. Is it okay? Yes, I think the slide is now sharing. I will see whether the next slide comes or not. Yes, it is coming now. So there are various different categories of the hurricanes, or we can say cyclones. And these depend upon category one, depends upon the wind speed. If it is 119 to 153 kilometers per hour. Similarly, wind speed, if it is 154 to 177 kilometers per hour, it is category 2. Category 3 is 178 to 208 kilometers per hour. Category 4, the wind speed is 209 to 251, and greater than 252 is the category 5. I think now the screen is just sharing. Yes. When I'm trying through full screen share, it is not sharing actually. Is it clear now? Are you able to see me?
Yes, sir, we can see your slide.
Yeah. Okay. Then okay. Because I'm going continuously and the slides are not seen, then it will be of no use. Okay. So here are certain important events that have occurred in the up to October 2016. right from the oldest event which has been dated is about 1912, or maybe in China, number of events occurred in China, Bangladesh. The number of people died, we can say 3 lakh, 1,38,000 and so on. Like this, certain events that had occurred on the surface of this earth, and they have caused the large devastations in this particular area. Here, these are the slides that shows these how hurricanes hurricanes in Hago 1989 caused the event of the cyclone and devastation 1989. Another slide which shows the Hurricane Katrina, which has caused a large amount of death again in 2005. These are various different data that have been collected. Here are some other examples which we can see: Cyclone Amphan 2020 in the Bay of Bengal. Another hurricane, the collage of Riot Hurricane, we can call number of the cyclones have been created within this area. NASA has put out filmed out this in 2019. So these are the various events that had occurred in this particular part of the world, and it has caused large devastations in these areas. Use of remote sensing and disaster management now for tsunami. That is another we can say disaster that I'm talking about. Like the coastal flooding tsunami event may be modeled by using the GIS. Complex computual fluid dynamics (CFD) requires for very detailed bathymetric and topographic data received from the remote sensing mission. Well, these type of data is very essential, and from that data, the things are done. Now, how these tsunamis are generated? The earthquakes and landslides that contribute to tsunami formation can be assessed by different remote sensing techniques. Tsunami, one of the deadliest that has the Indian subcontinent had witnessed in 2011 earthquake of Pacific coast, and another that is 1883, the disastrous Krakatoa volcanic eruption caused the 36,000 deaths. 17th August 1976, the Moro Gulf in Philippines caused 8,000 deaths. 26 December 2004, the more than 2 million deaths in that is Indian subcontinent, we can say, and even Japan, Indonesia, India, Philippines, Maldives, Sri Lanka, Thailand, all these countries have witnessed these type of catastrophic disasters called tsunamis. So here are certain figures. This is before the tsunami, and the next figure is just after the tsunami, how the changes has taken place. We can see here the figure change where this tsunami has caused the destruction in a particular area. This is the part of a Asian country that can be seen here, that how beautiful this island-like situation is there. But as soon as it is hit by the tsunami, the change we can see. Witness the change. Look at this. How this immediately changes to a devastating, all things are there washed away because of that huge, big tsunami waves. So here is another same figure, I think so, but that has been hit by the tsunami. These are the areas which have been completely submerged because of that is swept away from this particular area. Aerial photo of Minato devastated by both earthquake and subsequent tsunami in this particular area. So these are the we can say disasters, and how can be disasters mitigated, that will be discussed later on. Management of this disaster through drought-prone areas or droughts, we can say. It is generally defined as a deficiency in precipitation over an extended period of time. If this occurs, there is a resulting of a water shortage, and that causes the disaster through the evaporation process more. 4 basic approaches are there: meteorological, hydrological, agricultural, and socio-economic. Climatical variability is there. That climatical variability, if it is there, if precipitation is very less than the evaporation, then temperature, if it is more, in such areas, droughts come. And we know that Indian subcontinent have witnessed several times such type of droughts. El Nino and La Nino, also La Nina effect, also have this type of the impact on formation of this disasters. Then deforestation is also one of the causes said for these drought disasters. Over extraction of water, groundwater through the rivers, lakes, and even aquifers and through the groundwater also may be one of the cause for the drought. What happens when droughts takes place? There are certain figures we can see which illustrates the fact that how this drought can cause the problem. Droughts have been witnessed in several countries such as Afghanistan, Iran, Myanmar, Pakistan is there, India, Sri Lanka and Nepal, even African countries also witnessed several disasters of drought. This effect of the drought is agricultural challenge, water supply issues, ecological damages, and socio-economic impacts these droughts can cause on the humanity.
Regression analysis.
Yes, okay, I'm continuing. Are you able to see the slides and presentation now?
Answer.
Okay. Yes, yes.
Yes,
So I
sir,
will
you are visible and audible, sir.
glimpses that have been shown here, human disasters, that is in Karnataka, we have such type of disaster of drought, even
FDP, Vadiyar.
Sir, please unmute your mic.
yes, I think it is unmuted now.
Yes, yes, yes. It's audible now.
Okay. Yeah. So there are various different types of drought-prone areas in the world, and how these droughts are generated and how we can mitigate these droughts that can be discussed in this particular part. Here is an example how these satellite images, they show the NASA showed the extent of a drought in Lake Mead, the largest reservoir in the United States. The change was captured by comparing 2 images. The first one obtained by Landsat 7 on July 6, 2000, and the second one was Landsat 8 on July 3, 2022. Here it is the same river, that is the Virgin River, and it's a lake over here. 2000, this image, look at this water, how deep it was, black showing the deepness of the water, depth of the water here. But now if you see in the 2021, this part is becoming a dry. Even this part, which was having a lake over here, is also dried. And the lake arm, that we can say the Overton arm, has now depleted the groundwater, and the green portion is visible over here, indicating the less depth of the water. So in 2022, further it increased more, and the now only very few part of this lake is visible there. This way, the remote sensing as well as GIS can help in understanding the different, we can say, the disasters all over the globe. Here, the next one is we are talking about earthquake. The aftermath of an earthquake is clearly highly visible from space using high resolution satellites and aerial photographs. Detailed image analysis can assist the ground crew to locate or location where the electric pylons or ruptured gas oil pipes, etc., are located, that so that the immediate attention can be paid there. Another I have to go manually here. Okay. So earthquake disasters, 70% of the earthquakes are reported from the zone of a circum-Pacific belt that is known to everybody. Japan, once in every 10 year witness this type of the catastrophic, we can say disastrous earthquakes there. China also, one of the deadliest earthquake of China on 28 July 1976 caused 240,000 deaths. Philippines average 5 earthquakes per day. India and Pacific Ocean seismic zone, Indian Ocean seismic zone, Nepal, Afghanistan, even part of Iran and Pacific, also Turkey and various other countries, US also, that San Andreas Fault earthquake and other earthquakes, number of earthquakes are there, which are there on the Earth's surface. Several faults generated, rather we can say tectonic or the circum-Pacific belt earthquakes are there. Here is an example showing the before and after of February 8, 2023 earthquake that occurred in the Turkey. That was the Turkey earthquake. Look at the stadium over here and the buildings and other things which are there. These buildings have totally collapsed, but now the stadium has been used as a shelter zone in that particular area. So here the people are staying in the tents and other things. This type of activity can happen. Here are some glimpses which indicate the magnitude 7.8 and magnitude 7.5 earthquakes that struck in the Turkey area. The same 2023 earthquake occurred in February. Now here is an example, the two different scenario, top two figures and bottom two figures we can see. The top two figures are from our area, that is Latur Killari, witnessed the earthquake in 1993. These are the top two figures illustrating how the devastation had taken place, and about 10,000 people died in this particular earthquake. The construction was very poor, that in the form or in the sense of the earthquake prone areas, that was the stone construction or pebble construction was more there, and the soil was used, or many places some we can say calcium carbonate was used for the construction purposes. But in the lower two figures, the figure in the bottom left indicate the earthquake caused this type of a destruction, but the collapsed settlement are in a plain way. And here the second figure, that is the bottom right, it shows the houses are safe even in the earthquake. So this way, they are these type of areas, if are there, they have to be managed. These areas have to be, we can say, perfectly rehabilitated, and the houses and the construction work should have been taken as per the norms required for the safety from the earthquakes. Another disaster over here, that is a landslide disaster. In India also it happens. About 40 million hectares annual flood inundation can cause the landslides. Bangladesh also witnessed several times this type of flood and landslides. China also, Sri Lanka also, number of flood and landslide aspects are there. This is one of the example which is recent time India witnessed in 2024. That was the we can say landslide took place in Wayanad district of Kerala. If you see this left side figure, this is the particular river. Here is a debris which is of old landslide debris. But this right side figure, which shows the crown of a new landslide, and it has caused several deaths and the loss of the property in this particular area. Here are certain other examples from different parts that to be in China. Figure A shows how this devastating landslide took place. Catastrophic landslide have stimulated application of remote sensing in China. This is the Singmo landslide. Baihe landslide is in second figure, where the landsliding zones can be seen, how much collapse of the material place in this particular area. Third figure is also from the same, from the China, that is a Sedangyu landslide that has taken place in this particular area. So these landslide mapping can be done, but okay, how we can prevent this landslide? Is there any chance to prevent? Actually, there are less chances for prevention, but still we can adopt certain engineering methods so that the landslide can be prevented. Now, by the means of the grouting, by means of putting the iron mesh there, so that actually while constructing the road or while constructing the bridge, when they are there, and by locating the village or the town in a particular area, we must have taken into consideration the tip of that particular strata, where it is dipping, whether it is dipping towards the particular, we can say the locality, or whether it is dipping away from that particular locality. These care must be taken, and we can say preventive measures, if we add there, definitely some of them can be mitigated, some of the loss of the property or life can be saved. That way, the mitigation methods we'll be discussing later on. Another example, this is the left and middle image where acquired from Landsat data, 15 September 2013. So this is 15th September 2013. This is another 18th September 2014. The same these two figures are of the same area. Here is the mark out landslide detection, possible and probable detection markings are done. So the scientists, the geologists, the earth scientists, they can always use. And we heard during a landslide that somebody has a caution that yes, there should be care should be taken and other thing. So that happens because the scientists, they can study the stability of the slope, the stability of that particular terrain, so that it can be mitigated properly. So these are the this area which do not have more, we can say, the devastation of the landsliding, but here 1 year back, but here when we see in the 2014 how much devastation has taken place in this particular area, the roads and the other, we can say, transportation measures are been hampered, totally destroyed in these particular landslides. They can happen in this particular areas. This is the way another example of landslide. Western Ghat witnessed such type of Konkan area. The landslide had occurred and the whole, we can say, track are being loosened, Konkan railway. Now another, you can say, the volcanic eruption, how the volcanologist can forecast the volcanoes, detect, tracking eruption activity, that can also be done. The eruptions are often preceded by a number of indicators that are detected from space. So first of all, when a volcanic eruption has to take place, then thermal images can produce that some activity may be going on here. Then after that thermal activity, then we can understand, yes, there are certain emission of the gases. And after that, some volcanic bombs and other thing or volcanic ash will come out. And later on, the lava will come. All these activities, when we can see, they can be continuously monitored and visibility can be made through the remote sensing, and some predictive models can be generated through the GIS platform. Here are certain examples how these volcanoes can take place on the Earth's surface. Mount Etna, maybe the number of volcanoes that are there in Philippines, Indonesia, even in Italy, Sicily, and other volcanoes. They are continuously Hawaiian Islands volcanic activity. This is even recent times, several volcanic eruptions have taken place, and large number of the we can say the videos are available regarding showing how the lavas are flowing. So in such type of situations, how we can act, how the shifting of these people can be done, the houses and important documents can be carried out and shifted to the another region. These are the glimpses that indicate lava flow from eruption, flow across the major road and close down the Blue Lagoon. Here is a lagoonal lake, and these roads have been closed. It is there from the NASA. Now, after completing all these disaster activities, how these can be managed and mitigated, and what application of remote sensing can be done for these different activities or different disasters, earthquakes, volcanic eruption, landslide, flash flood, major floods are there, storm surge or hurricanes, and even tornadoes, droughts are there. Then what can be the preventive measures that could be applied? For example, for prevention, we can say mapping geological lineament in land use patterns. Even some places we can go for the paleoseismic evidences. If the paleoseismic evidences are gathered and correlate these evidences through the new seismic activities, and if that is correlated, then recurrence of the earthquake can also be predicted. So that prediction can also be possible through the these different studies, researches. Preparedness for earthquake, the geodynamic measurement of the strains and stress and strain, and according to that, the houses should be like that. Locate the stricken areas, map the damaged areas that can be done for the relief. Volcanic eruption, topographic and land use maps can be used. Detection, measurement of gases, emanations there. Similarly, landslide, if it is there, then topographic and land use maps can be prepared. Rainfall data and slope stability are very essential aspects for understanding the preparedness or for warning purposes. Mapping the slide areas, flash flood or major flood or storm surge, etc. When they are there, the meteorological data very important for these type of the floods and other processes. Hurricanes, the synoptic weather forecasting is very essential for that. Map the extent of damage and so on. For disaster mitigation methods, education is very essential. Educate the people who are there. Those are the witnesses of these type of events or the disasters. Train them, know them, how we can prepare for these, how we can mitigate from this type of catastrophe. And there is a development of expertise in many fields should be there. The engineers, the professors, even the officials of different organizations who are government agencies who are looking for these type of the mitigation methods. These strategies for disaster mitigation are the community resilience, public information and warnings, long-term vulnerability and reductions there, operational coordination required, planning is very essential, threats and hazards, identification zones and identification of threats and identification of hazards during this type of activity, risk and disaster resilience and assessment like this, all these are the cycles of mitigation method. Before disaster, during disaster, and after disaster, how and what things can be done for mitigation purpose. Develop preventive laws and regulations, implement advanced code and standards, establish zoning requirements, buy insurance, contract barriers, construct barriers actually, preparedness required for before the disasters, stock disaster supply kit, whatever the kit is required for a particular disaster, that disaster kit must be stocked. Develop mutual aid agreements and plans, train response personnel and concerned citizens, prepare shelters and backup facilities. So whatever the we can say the disaster is there, even we have 2020 to 2021 witnessed this pandemic of the COVID-19, and how we tried, how we prepared ourselves, even though some loss was there, but we tried, we created different shelters and the different hospitals. Even the stadiums are converted into hospitals, even the colleges and other places have been converted into the, we can say, hospitals, and we tried to help the people. We created some vaccines and then we tried to mitigate that disaster. Fortunately, fortunate enough that we have covered or recovered from that disaster also. Now, during disaster, the responses search and rescue identification, identify affected people, assess the initial damage, provide first aid and humanitarian assistance to them, open and manage the shelters, recovery after the disaster, how we can recover. Debris removal is required in many cases. Maybe the hurricanes are there, floods are there, or earthquakes are there. Several disasters are there, but debris removal is one of the prime activity that can be done. Precise damage assessment should be carried out. Infrastructure and infrastructure destruction and reconstruction is required. Restore the livelihood first, and community development is also be required. So these are some steps that are to be required during the mitigation. Disaster management cycle, once again over here, for the disaster management, preparedness, disaster event, relief, rehabilitation, reconstruction, mitigation, further goes on. This is a complete cycle that can be called as a one waste cycle of 2000 that has been given by One Weston. Overview of forecast fire, wildfire, disaster management. For fire and wildfire, what type of the prevention events and coping management and regeneration activities to be carried out. Here is the fire for this is regarding the disaster management of a fire. So non-time critical information is required. Vegetation, biomass, moisture, permanent water mass, and risk analysis, hazard map, etc. are to be prepared for the prevention from the fire. These are required, and many scientists, they are carrying out this type of research, but unfortunate, sometimes cannot be predicted, and even sometimes predicted, we may take attention or not. According to that, the event happens. If the event happens, then coping management, how we can do. Support for time critical management tasks, early detection, disaster situation, monitoring. Then COPs should be made, demand spread modeling can be done, situation monitoring, that is water level, fire watch, and etc. All this can be carried out, and then the regeneration activities are to be done. Some flood-related mitigation methods are there. For that, preparation is required. That means afforestation should be avoided. Contour farming must be done, so that if cities are carried, if cities are made in the mountainous hilly areas, then it may sometimes store or stop the flood event, may help in minute amount for the flood event. Contour burns are required. Check burns are required in many places. Gully plugs should be carried out, should be done. Bank protection methods must be applied. Diversion drains should be prepared. Strip cropping must be taken. So and so, these different processes, if they are applied, even some amount of the flood hazard can be mitigated. Not we cannot solve, but okay, we can mitigate some. We can mitigate some of the disasters from this particular activities done. Similarly, for mitigation in the drought impacts, while droughts are challenging to control, there are several effective strategies that can be applied, such as water conservation. It is very essential for all the type of activities. Water conservation is one of the very important, we can say, from saving us from the drought and the scarcity of water and other activities. Water conservation, implementing techniques such as rainwater harvesting and drip irrigation can help save the water. Drought resistant crop should be planting the crop that can thrive in low water condition and can ensure food production. And even during dry spells also, these type of the plants can help us. Reforestation efforts must be taken. Restoring the trees cover can help enhance the rainfall and improve the local climatic condition or local climate. Education and awareness, as we talked earlier also, is very essential for any type of disaster situation, disaster. Informing communities about what water preservation practices, as well as better management and precious resources to be stored, to be, we can say, conserved. These are the things very essential for even drought prone areas. Earthquake. What are the earthquake and how this can be prevented and other things can, we have discussed, not prevented, but we can prepare for that. Here are some, we can say, glimpses see here. So identify the potential hazard areas, create a disaster preparedness plan, prepare a disaster supply kits, identify your building potential weaknesses and begin to fix them. Protecting yourself during earthquake, shaking, drop, cover, and hold. These are the three important activities: drop, cover, and hold, that I will be telling you. After the earthquake, check for the injuries and damages. When safe, continue to follow your disaster preparedness plans. In the second figure, we can see, the important aspect is that during earthquake, don't get panic, drop. So we can have some drop effect that it should be covered with some hard material, maybe some places stable. Hold, catch it, hold it so that you should not be thrown away, you should not be moved away. Then protecting your head is very essential. Turn off the gas and electric phases, whatever the things which we use in our household activities. Use the fire extinguishers. Find a way out, easy way to move out from a building, from top floor or whatever it may be. So all these preparedness activities are very essential while the earthquake hazard. Tsunami, maybe we have witnessed that tsunami, but the large part of the earth, especially Japan, have affected by such type of tsunami activities, and therefore they have made their national tsunami hazard mitigation programs, hazard assessment, warning guidance, and mitigation methods are the important aspects that have been used by these Japanese people to save from earthquake and tsunamis. Hazard assessment, developing and standardizing and improving tools that show how tsunami could affect the people and property. Tsunami inundation, flooding, and evacuation maps should be prepared. Warning guidance are very essential while tsunamis are there. Alert of the tsunami. We have even that tsunami in 2004, we have alert and we have saved several people. Unfortunate for some other people. Providing input to the operational US tsunami warning system to help refine warning system, messages, graphics, procedures, exercises, and dissemination systems are very essential for warning purposes. Mitigation methods are again very essential aspects, using education and outreach to increase the awareness and encourage the preparedness. Promoting and providing guidance on other risk reduction activities, vacation planning and integration of tsunami risks and other policy planning, etc. should be carried out. Here is another example of earthquake case. Now I am moving towards the last part of this presentation, that I am now talking about the case study of Latur area earthquake. In this Latur area, 1993, September 1993, 30th September 1993, Latur area, especially the epicenter at Killari, witnessed a very devastating earthquake in peninsular Indian Shield, especially in the Deccan Plateau. We see that Deccan Plateau consisting of Deccan volcanic basalt. So this Deccan volcanic basalt, even it is a basalt in condition, which has solidified since, we can say, 65 million years to about 4.3 million years and so on. This area is considered to be a very, we can say, stable continental landmass or stable landmass. But still, this earthquake of Killari and 1966 earthquake of the Koina has put some cautions among the scientists, and then they started working. Then we have detected several different type of the lineaments that is called as a Kurdwadi lineament, Godavari lineament. All these lineaments have been found out. Katam lineament is there. Some lineaments that are been found at, we can say, the part of Kinwat area. Many areas, they are seen as a lineament zone. What are these lineaments? These lineaments are supposed to be the fault activating lineaments. Maybe some are the fault activating, and therefore we have even in the, we can say, peninsular shield zone, the earthquakes are found. These earthquakes may not be of more than 7 or like that grade, but even 6.3 magnitude earthquake caused that near about 10,000 life in the Latur area. What this indicates? For that, we, from myself, from my student and my group, started searching and started working on the, even some, is there any paleoseismic activity of that Killari area in the Ter River? So we started research on the morphometric and the geomorphic indices of active tectonic aspects of this particular area. And then we come out for some primary conclusions that we can say, which have been published in the Quaternary Science Journal of Germany, and other we can say research papers are there. So I am moving towards this aspect. I am showing here the case study of Latur earthquake. This is the tectonic map of India. Historic earthquakes are being shown in this particular. This has been taken from Wilhelm 2004. The values in bracket indicate the number of casualties because of the earthquake. Here are some. Now we know that Indian subcontinent with the Himalayan terrain, that is a circum-Pacific belt, and the Alp-Himalayan zone is one of the, we can say, earthquake-prone zones in the world. Circum-Pacific belt is known, and the earthquake-prone zone is the Alp-Himalayan, we can say, tectonic belt is also one of the. So there are various, we can say, Kashmir earthquakes several times happened, Kabul earthquake several times happens. Then we have Uttarkashi, Chamudi earthquakes are there, Kumaon earthquakes are there, Nepal earthquake of 1833, 500 people died, Assam earthquake of 1950, Shillong earthquake of 1897, 1,542 casualties are there. Like this, several casualties, and Bhutan earthquake of 1 lakh, rather we can say 17 lakh 13,000, rather it is more than 70 lakh 13,000 that casualty was there. And in this was this happened actually within the 1713 and 1947, the earthquake in Bhutan is there. And this time we have these earthquake in Latur area also. and Koina area. Therefore, this zone becomes a zone of area of researcher, where they have concentrated on lineament, maybe the fault lineament. This is also another. So here is a tectonic bulge seen in the Indian subcontinent, and here are various different earthquakes that are found. Now we are concentrating toward this part of location map of the Terna River. This is the Terna River. It is in Latur and originated in Osmanabad district, and now the Latur district. It is a tributary of a Manjra River. And here, this is a Killari area. This is Aurad and the other areas. And here at this place, the Ther Reservoir is there. Ther Reservoir consists of, this Ther is a locality village where we could find out the paleoseismic events that had happened even before 1,500 years back. That is detected, that is found through the, we can say, age dating method. We will come across this several slides through this presentation. This is the drainage map of the total Terna River catchment. We have here A to D, this bigger one, these bigger dots you can see here are the lineaments indicating subsurface faults. And here that black dot is indicating the Killari area. 1, 2, and 3, the triple point junction is there at the source of the Killari earthquake. We can call it as the epicenter of the Killari earthquake. The triple point junction of a fault lineament is detected. Now, if a fault lineament is there and have some old occurrences or evidences of a paleoseismic activity, then why, whether this area is having some potential of searching out the trend in, we can say, the drainage pattern. Is there any particular trend in drainage pattern? Is there any anomalous drainage pattern found in this particular area? That case study I'm trying here in this particular presentation. Similarly, while moving or while searching, we have found out one IRS-1C panchromatic data of the Terna River, and we could found out some paleo channels over here. This is the present Terna River, and this indicate here one, even here also, even this area also. Many places we can see that there are some paleo channels. That means earlier the river was moving in this direction, but it has now changed the course. So like this, there are several different channels are seen in this particular figure where we have some anomalous pattern, and paleo channels have been detected in this, we can say, the peninsular shield or Deccan basaltic plateau. Now here is the main lineament which we are concentrating on, that is called as a Kurdwali lineament zone. On this Kurdwali lineament zone, there is the, we can say, this part Kurdwali lineament. It exactly shows how the straight line figure is developed in the rivers. Maybe this river Sina, maybe the God River, all these rivers, even the Bhima, show a typical trend, and similar such trend is also shown by the Terna River. This is that Terna River, and here is that Killari earthquake zone, and here is a Latur. Similar pattern is followed by the Latur area, and these type of the lineament zone, this we can call as a Kurdwadi rift. There is a Godavari rift, and there is a Sonata, that is a Narmada and Son rift. Like this, and another one is there, Koina rift is also there. Koina rift, the Kordwadi rift, Godavari rift, Godavari Pranhita rift, we can say, and Narmada Son river, Sonata lineament. All these are the lineaments which are the, we can say, intermittently they are becoming active. These are the earthquake that we have seen at Koina also, maybe the part in we can say different parts of this lineament showed earlier paleoseismic evidences, and even in the Terna River, this is found. So here is the lineament map of Terna River. Look at these different type of faults. The Terna Killari lineament, the The other different types of lineaments, they especially mark the, you can say, crisscross pattern of a jointing there, and fault lineaments are there. And along these, we have found anomalous drainage pattern. How this anomalous drainage pattern is there? Look at this. There are some rivers which should have joined the major river in a short distance to the major river. But instead of joining the short distance, they followed the path of the river and later on joined. Some of the rivers, they followed opposite to the path of the river and then joined. Even some places we found the convergence and divergence of the stream parallel to the major river. This type of effect, they can clearly understood the fact that yes, because of that lineament, because of the earlier faults, there are certain anomalous drainages developed along that particular river. This is the way we tried and we searched out some anomalous behavior of the river, and a sudden bend, 90-degree turn, instead of joining the short distance, join a long distance and parallel to the river. These smaller tributaries catchment are parallel to the main river and then joining after the certain distances. Like that, the different scenarios have been found, and these scenarios have been considered as anomalous zones in this particular river. Now we have calculated several different aspects of the morphometric analysis, such as the bifurcation ratio, length ratio, then basin configuration, drainage density, many parameters which are required for the morphometric analysis also have been carried out. Not only that, we also carried out the 5 geomorphic indices of active tectonics for the same river. What are these? Basin elongation ratio. Similarly, the basin asymmetry factor. If you look at the drainage basin, we can see that the southern portion is less than the northern portion. That means the river has shifted towards the southern part as compared to the northern part, illustrating, indicating the asymmetry. And several different fragments of this river basin have been carried out, and they have been assessed through the stream gradient and length ratio. Hypsometric integrals of all these, the 36, we can say, sub-basins of this river have been carried out. And even the valley floor width and valley height ratio also have been carried out. Many places where the activity is seen, they show the anomalous behavior of the river. So anomalous behavior indicates some activity might have happened, and then we try to get field evidences in the form of fault, fold, and dated the charcoals from that, and we have come to conclusion for this. I will be showing these again. So here is the morphometric table, and if you look at the morphometric analysis of this Terna river, the first one is the stream order. Up to 6th order streams we have found, and a number of streams we have found. This particular area is like this. And when we see the bifurcation ratio of this river, it is seen that from 1st order to 5th order, the bifurcation ratio is about 4.1 to 4.6. It is a normal, neutral, natural. But as soon as we see the bifurcation ratio between 5th and 6th order, the drastic change is visible. It is a 10. So bifurcation ratio from 3 to 5 is supposed to be the normal, but more than 6, we can say more than 5.5 or more than 6 is abnormal. So here, even the bifurcation ratio and even the length ratio, both of them, when plotted through semilog graph, look at the semilog graph of this one. Look at. In this semilog graph, we see that from 1st order to 5th order, the linear matching is perfectly made. But the 6th order is very much deviated from this linear trend. Similarly, in another semilog graph, look at this length of the, we can say mean stream length of the area versus stream order. It shows 1, 2, 3, 4, 5. They are matching completely, but the 6th order is deviated. All this indicate that yes, there can be a structural control in this particular area. And this structural control can be seen through some of the evidences. Here are drainage basin configurations. I will not go into the details of what we have calculated these total basin area, maximum basin length, form factor, basin perimeter, number of circularity, important aspects I will be concentrating on: circularity ratio, compactness ratio, then elongation ratio, then we can say the drainage density, stream frequency, all these parameters of this particular area has been carried out. And these parameters, especially the parameters of active tectonic, they show some. Here is another parameter that have been carried out for relief gradient. I don't want to go into the details of this because we are mainly concentrating on the this is hypsometric curve calculated for this particular area. But here are certain we can say sinuosity parameters are carried out at these different places of the river, right from first one to the 20th one near the confluence toward the Manjra River, this Terna River basin. The segment to show the sinuosity parameter have been carried out again at some places where the anomalous drainage patterns are been found. We could have recorded the different, you can say, anomalous behavior of the sinuosity of the channel. Here is the geological map of this particular area. It indicates the flood plains, older flood alluvial plains are there. The brown, rather we can say this gray color, it indicates the compact basalts are there. This white color indicate the amygdaloidal basalt flows are there. These are the basaltic flows. And also we have red ball bed in this particular area. So these are the red ball beds in this particular area, and the other rocks are found. All these rocks, they are when found out in this particular area from 739 meter high above the mean sea level, that is the contour height, up to 500 and you can say 30. Then we found near about 11 flows of the basalt, 11 flows of the basalt, of which 2 are a red ball bed, and the remaining rather right from the first, second, third. So all these flows are found from 746 up to 551 meter depth from this particular. So this we have found out the basaltic flows. But now we are concentrating on, after understanding that the area is having some potential for searching out the paleoseismic activity, then we found this area a vertical section in the Ther village, the village called Ther. At this Ther village, we found here the fault is there. This fault is there, and it's a close view I will be showing in the next slide. The faulting is visible over here. The shortening is visible over here, and the folding is visible on this particular area. This is a sedimentary site where it is above, near about 40 feet high or more than that high above the present level of the river channel. What this indicates? Present level of the river channel is 40 feet less than, or we can say down to this particular area. This particular, we can say, a bank of the river. That means these are the river surge flood deposits that have been deposited in this particular area. And river has gone down. That means some activity might have happened, and during that activity, the fault is generated in this particular zone. We have dated this fault. This is 1850 plus or minus 120 year before present. And this site has been dated 570 plus or minus 340 years before present. And here, these are the recent soils, recent sediments, we can say. Another close view we can see here. This is the close view of the photograph showing flexure and horizontal shortening is visible over there in this particular figure at left at Ther village again. Another, that is a close view of the fault, close view of offset in the middle of the Ther section. Here is that fault visible. If we see here, the age of this charcoal found in this particular bed is 1850, and above that it is about 1500 and more. Like this indicates that this activity might have happened about or more than 1,500 years before present. Here are some examples we have collected from Killari area, near Killari. These type of faults are also detected from the white sediment or white sediment surge deposits which are found in Killari area. The people, they have used this soil for construction work, and the pebbles and the boulders which are there from this river have been used for the construction of houses. And because of that devastating, even though it was of a less, we can say 6.3 earthquake, but it has caused the damage more, about 10,000. Here are some sedimentary rocks that have been dating data. Some physical research laboratory help us in dating this, and we also paid some for dating this sample by carbon C14 dates, and we found that the carbon C14 dates, they are lying from 570 up to 1,850 years before present. This indicates that yes, there might be certain thing that had happened in past also, which is also reflected on the river streams. Even some construction sites are visible there. These construction sites also show some, we can say, offsets are there. Like this, these are the activities that have been traced. It has been published. The satellite map or image of this particular area also has been found out, has been determined by my student through GIS and remote sensing data. Here is a digital elevation map of that particular Terna river we have carried out. And here is the end of this, we can say, because this lineament shows northeast, southwest to northwest, southeast trend. Some are east-west and some show west-northwest to east-southeast direction, which control the basement structure in the state area. The sinuosity values indicate rejuvenation of the area, leading to the dominating effect of topography on the sinuosity of the river channel. The break-in slope along the profile is also indication of the quaternary tectonic activity or uplift in this area. And the radiocarbon dating of charcoal samples indicated that the event of a paleoseismic activity might have happened or might have taken place along the Terna River before, that is AD 917 to AD 1183, and even before that also at the Ter village. Thank you very much. This is the presentation from my side. If possible, any questions? Okay.
Good evening, sir.
Good evening. Good evening.
So,
Yeah, participants are requested to ask any question if they have it.
yes, ma'am. So, myself, Professor Dr. Sandeep Patil from Bharati Vidyapeeth's College of Engineering for Women, Pune. First of all, I would like to appreciate the very insightful, informative session, which enlighten us with the all national remote sensing and GIS related, and especially the case study of Killari earthquake and the case study outcomes are very much appealing to me in person, because I belongs to the district Dharashi Usmanabad, and places where I visited frequently, and I was the one among the hundreds and thousands who experienced the disaster on September 1993, all the three tremors. So it helped me the recalls of memory and the very devastating incidents in the Sastur and Killari. We could also contributed in some way as a social welfare in this incidents that time. So it was very well presented, and with nice outcome of theme of your study and the details about the Terana River, the Manjra River, and the all rivers, Bhima, Sina. These are the area where which I am quite familiar with. And I was one among the witness of the disaster happened there. So I closely associated with that area. So it was really appealing and appreciable case study and research carried out by you and your team. And it was very informative and insightful session, sir.
Thank you very much.
My question is, recently have witnessed, the world has witnessed the disaster of fire incidents in Amazon, USA.
Yeah.
So, despite of all the technological advancement, USA become the developed country and having highest advanced technologies and all. So why can't we, or what is the limitation of current remote sensing technologies or GIS technologies? What is the lacuna that we can't prevent, or there could be alarms in advance so that we can save the human lives and the natural resources losses?
Yeah. Yes, sir. It is a very debatable question because we know that it is one of the highest powerful country could not save. Several reels have been come out showing that how it could not be prevented. Basically, the thing is that the event happened in a very fast manner because of the La Nina effect that has taken place in this particular zone. It has tried the several places in that area, and whatever the friction has occurred, that friction might have caused the burning of this. And simultaneously, because of this wind effect, the thing happened very quickly. Too much the speed was there for that particular event, and therefore, even though if it is a big shot in the world, could not prevent that. Maybe this thing happened. Unfortunately, this data for satellite remote sensing and other is not possible in a very, we can say, in short period of time. Even though the people, the scientists, they may move on for that, and this activity might have opened the avenues for searching out what more predictable things can be done. But unfortunately, it is not possible, and because of that thing, this devastation happened there in this particular area. Yes, sir, it is a very debatable question. Maybe some knowledge come out after this, and we can have benefit for that. Thank you very much.
Thank you so much. Let us be hopeful, and we have to be, and hope
Yes.
that the future technologies would be efficient enough to predict in advance so that we can save whole human lives and the natural resources in the world. Thank you so much.
Thank you. Thank you.
Thank you, sir, for asking question. And thank you, sir, for answering and such a wonderful session, actually. Any other question from the audience? Okay, okay. Thank you, Sheikh, sir. It was wonderful session. And thank you for your valuable time. In spite of your busy schedule, you have given us time. Thanks once again. Thank you.
Thank you. Thank you very much.
Yeah, yeah. The participants, after completion of the last session, you can check your attendance, and the quiz status also will update you. The work is in progress, so we will update you the details. Okay, at around 6 p.m. the next session will start. So till that, we may have a 5 p.m. the next session will start. And so maybe another 5 minutes we have time in which the next speaker will be online, will be onboarded, and will have his presentation and everything ready. So at 5 p.m. we'll start the next session. Thank you.
So I will leave, madam. Thank you.
Yes, sir.
Okay.
Yes. Thank you. Good day. We are starting the next session in just 5 minutes. Just give us 5 minutes. Good evening, Kanu sir.
Hello.
Access is, yeah, good evening. So access is given to you. You may just verify. Yeah.
Excuse me, ma'am.
Yes, sir. Yes, sir.
Ma'am, I want to know what will be the platform for the quiz and which time it will happen.
Quiz and feedback, overall feedback, both will be available on ATAL FDP portal. You have to log in into your portal, and 6:30 to 7:30 in this slot, the quiz will be active.
Okay, ma'am. And how many questions are there?
25 questions are there.
Okay.
2 marks per question. So,
Actually, one of my colleagues was checking and he was saying that quiz is not uploaded yet. So that's why I asked.
yeah, it's at 6:30 na. Now it is 5 o'clock still na, 4:58.
Oh, okay, ma'am.
So it's 6:30 it will be, and we will give you information prior.
Okay, ma'am. Thank you.
Okay. So Kanu sir, are you able to upload your PPT? Okay, fine. Are you can we start, Kanu sir?
Yes.
Okay. Good evening, all. It is an absolute honor to introduce our distinguished speaker for today's session, Dr. Kanu Charan Patnaik. He is a senior scientist at the UK Met Office and a visiting scientist at University of Leeds with an impressive career dedicated to climate change research and sustainability. With over 17 years of experience, Dr. Patnaik has worked with prestigious institutions such as NCMRWF India, IIT Delhi, and National Environmental Agency in Singapore. His contributions to climate science are vast, having authored 32 peer-reviewed research papers and written books on climate change, impact, and AI applications. His research primarily focuses on climate extremes and sustainability, addressing some of the most pressing environmental challenges of our time. Dr. Patnaik has led groundbreaking projects, including the Amazon Phase Project, which studies the effect of elevated CO2 on the Amazon rainforest, and climate risk analysis for financial institutions, in collaboration with UK Centre of Greening Finance and Investment. He has also worked with Cambridge University, analyzing the impact of climate change on the global macroeconomy. His expertise and contributions have earned him prestigious recognitions, including being named a fellow of Royal Meteorological Society in 2024, and receiving Climate Change Leadership Award for his outstanding work in the field. Beyond research, Dr. Patnaik is deeply committed to education and mentorship. He has guided PhD and master students in climate extremes and sustainability strategies, sharing his knowledge to inspire the next generation of scientists. His passion extends beyond academia as he actively engages in climate education for rural students, advocating for sustainability and encouraging young minds to take action for a better future. We are truly privileged to have him with us today. Please join me welcoming Dr. Kanu Charan Patnaik. Thank you, sir, for accepting our invitation. Over to you, sir.
Can you hear me well?
Yeah, we can hear you well. Yeah,
Okay.
you're audible.
Can you see my screen?
Yes, sir. Impact of land use. Yeah, we are able to see the screen. Thank you, sir. Over to you.
Okay, it's changing, right?
Yeah, it's changing. It's changing. Yes.
Okay.
Yeah.
Everything worked well. Okay. Thank you. Thank you very much for the nice introduction, actually. So, okay. So I'm Kanhacharan Patnaik. I'm working as a senior scientist at UK Met Office. So next to 1.5 hours, I'm going to tell you about what is climate change, what is different type of land use, land cover, and how it has changed South Asia, and what is the impact of this on our climate. So I have made some kind of simulation. So far you might have come across through other presentation that what is climate, weather, all these sort of things. Probably, I presumably before because I have seen some of the schedule, so they must have covered few of the things. Okay, so let me introduce myself. Okay, so I come from Odisha. I did my graduation from Odisha, then master degree in oceanography from there. Then I did MTech from Andhra University in atmospheric sciences. After that, I got my PhD in climate science from IIT Delhi. And then I joined Leeds University as a postdoc scientist. And there I work on the Amazon climate. After working 3 years in the Amazon, for Amazon climate, I work again on one more project on food security for Africa. Then I moved to Singapore for a couple of years. Okay. I worked there as a senior climate scientist. Then I came back to UK, been working as a senior scientist. Okay. And beside it, I'm also doing my executive MBA from Cambridge University. Okay. So recently, last year, I was awarded with the Fellow of Royal Meteorological Society. Okay. And also more than 35 papers I have published and about 2 books. One book I have authored and one book I have edited. And I'm a guest editor of few journals. Okay, that is all about who am I. Okay, let's start with some famous climate quotes. Okay. So I love these 2 climate quotes, I would say. So climate change is the defining issue of our time. And we are at a defining moment. So the famous Ban Ki-moon from former UN Secretary General, he said this one. I loved it actually. So really, if you can think of your childhood, you say that climate change is coming, it's coming. and all of a sudden that already we are there. We are already there. So we are at a defining moment of the climate change. And another one from quote from the former governor of Bank of England, Mark Carney, he said that the more we invest with foresight, the less we regret in hindsight. Okay, this is a beautiful thought. So this is true for all the places. Okay, you can think of anywhere. So the more you invest, let's say not only for the climate sense, I would say if your career also, the more you invest in your career, the less you regret in the hindsight. Okay, I could have done better if I could have worked, I could have invest more time on specific topic of this. So this with these two topics, let's start. What are we going to learn in this session? So another 1.5 session you have to bear me. Okay, so I will try to make it as interactive as possible. Okay. So few things what I will go through is that I will start with some basic knowledge of what is climate change, what are the different land use, land covers, what are the greenhouse gases and their role, and how can we predict them. Okay. And as you know, that my topic is the impact of land use, land cover, and and the greenhouse gases. So what are the motivation behind that the study? What are the key questions that will be addressed? And what are the methodology I have adopted? And the results what I have got from the simulations. Just let me wear my jacket, actually it's too cold. Sorry. Okay. And what are the takeaways from the study? Yeah. And it will be again, if you want to contact me, you can contact me. Okay, so I will share my contact detail at the end of the. Okay. Okay. So everybody knows about what is weather, what is climate. So all of us, we have read in our schools that weather is the short-term state of the atmosphere, like what is happening at the moment. So and the climate is the long-term weather pattern. So those are the basic things, basic difference between weather and climate. So so the times, weather and climate. So weather and climate are the two things what is defined by the time scale. Weather have different time scale, and climate has different time scale.
Participants, you are requested to mute yourself. Participants, thank you. Sir, please continue. Yeah.
Okay. So it is okay. It's keep coming actually. Okay, so the weather and climates are differentiated by the time scales, what we're looking at. So weather is that can change from minutes to hours, whereas the climate is quite long term. So generally, it takes about 30 years as the average period. Okay. So we can say decades to centuries. So what are the key component of the climate? That's temperature, precipitation. Precipitation means rainfall. Okay. So when you say precipitation, it may be liquid rainfall or the snowfall. That is also part of the precipitation, or hail. That's why we call that as precipitation. Okay. Then as I said, the difference between the weather is climate is just the timing. Okay. It's okay. Can I ask you to scan this code, please? Okay. Can you scan the code, QR code, and write whatever you think, like whatever when you think of climate change, what are the different terms comes to your mind? Just let's play around. What comes to your mind when you think of any? Okay. Like rainfall, temperature, cyclone that I have just written. So you just write down. So I will have the result here. Okay, whenever. Can somebody scan and can they get some Mentimeter? I want to make it a bit of interactive so that we can discuss more on that.
Yes. Yes, sir. We are able
Just
to
scan
see.
it. You will get a. Will move to this mentimeter.com.
Yes.
Okay.
We are able to see the questions.
Yeah. So just write down whatever you feel like. Whatever, when you think of the climate change, what are the different terms come to your mind? Okay. Just enter anything you like. There is nothing right, nothing wrong. Okay. So don't worry about I will be wrong or I will be right or what it is. Okay. Just want to make it as interactive as possible. So I have not seen any kind of anybody has okay, yeah, increase in temperature. Excellent, very good. Keep coming, keep coming. So there are 4 responses so far now. Okay. Anything. So there might be 3 option or 2 option. So you just fill it whatever you like. Like whenever so the climate change, when we think of that, it's sometime the increase in your temperature, daytime temperature, sometime nighttime temperature as well. Says that okay, the rainfall extremes are increasing. Somebody says that okay, the winds are blowing very strong, or the temperature, rain, wind very good. Okay. Okay. If you come from any hilly place, so maybe snowfall might decrease or something like that. Any floods are increasing, heat waves are increasing. Okay. Very good. Unpredicted environment. Hmm. Okay. Keep coming, keep coming. Okay. Consider rise and fall. Very good. 7 responses so far. So we are about 105 people. So just 3 or 4 people have responded so far. So can I request as much as you can, as much as you just scan the code. Okay. Scan the code and write whatever you feel like. So no answer is wrong. So think that way. So nothing is wrong. Whatever you write, that will be connected with the climate change. heat wave, flood, landslide. Very good. Any other thing? It doesn't have to be new. So you can repeat whatever other people, what you feel. So if you feel it is rain, so just write rain. If you feel it is temperature, write temperature. So don't worry that whether it is somebody has written, should I repeat that or not? Okay, don't worry about it. So, okay, so doesn't matter if it is there already. All you can see the result, right? Yes. The pollution. Okay, very rise in ocean level. Yes. So far 10 responses. Let's have some 30 or 40 responses. Then I will go get back to presentation again, so that just let's do it quickly. Melting of glacier. Excellent. So how does it work is, if you write rainfall or temperature again and again, that font will be bigger, so that I or yeah, look, wow. Ocean acidification. Is it really tilt? Okay. Noise pollution. Okay. Keep coming, keep coming. Okay. Carbon footprint. Okay, now. Nice. Fire. Yes. Wildfire. The latest Los Angeles fire. That is due to the so that's the part of climate change. Temperature, rain, wind, and anything, health issues. Yes. Yeah, so climate has a huge impact of the health. Okay. 18 response so far. So can I have more? Urbanization. Excellent. Okay. Urbanization also. That's a part of because of that, the climate change happening. Okay. What's anything? Extreme weather conditions. Yes. Yes, because of the climate change, extreme weather condition are increasing. Groundwater depletion. Yes. So that is also part of climate change. Yes, because of it, the underground water storage is decreasing. So more exploration is going. Shifting of weather. Yes, shifting of weather patterns. Great. Let's touch 30 response at least. Then we will get back to get back to the presentation. Let's have 8 more response, please. Few more. We have 108 people. Just 22 response so far. Anything? Anybody? There's no harm in repeating the same thing. There's no harm at all. Okay, good. Anything? Shifting of any considerable rise and fall, shifting ocean and extreme weather conditions, heat wave, unpredicted carbon. survival of human being. Okay, that's new. Yes, that's true. Yeah. Anything else? Anything else? Okay, what excessive mining? Wow, wow, great. Any other? That is also because of the excessive mining. That is also part of climate change. Okay, drastic weather change. Great. Okay. Okay. If nobody else want to join, okay, something new, something new. Vegetation decreasing. Great. Okay. Shall I go back to the main presentation now? One more came. Initiate Save Earth activity. Great. Okay. Okay. 27 response. Okay. So now I'm going back to the original presentation. Okay. Okay. So many responses we got because so everything is correct. Okay. So when we think of climate change, so basically what happened, the climate change refers to a significant and lasting changes in the climate over time. If you see the plot, this one, this is the land temperature anomaly distribution. So if you know about our Earth, so how the temperature is changing over the time. Okay. So this is just over the land. I have not considered the ocean. So look at the year, how the temperature is changing. Okay. So you can see by the time it is just moving towards the positive anomaly, towards more and more towards 1 degree, 2 degree, 3 degree, 4 degree. Okay. You can see that by 2020, it is almost more than 1. The peak is around 1. And when it was 1950, the peak was around 0 degree. And in 2020, it is almost more than 1.1 to 1.2 degree. And now 2023, the peak is around 25, 1.5 degree. So there are some natural causes of climate change. So like volcanic eruption, solar radiation. So there is also some human-induced change that is anthropogenic, like deforestation and some burning of fossil fuel. So another thing, and also the role of greenhouse gases in the global warming. So if you know about greenhouse gases, let me go to the greenhouse gases. So greenhouse gases, what happens? The greenhouse gases are the gases which traps the heat in the atmosphere. Okay. So it doesn't allow the sun radiation, solar radiation, or the heat from the ocean, from the Earth's surface to escape to this space. Okay. So what happens? The Earth receives heat from the sun in the form of solar radiation the in the shortwave range. Okay, because there's some law that says that the higher the temperature, the wavelength is smaller. So that's why the temperature and the solar radiation Earth receives in a shorter wavelength. Okay, and because of that, Earth gets heated, and as any object that is that get heat or that is higher than the absolute 0 degree temperature that emits heat or that emit radiation. So the average temperature of the earth is about 15 degrees Celsius. So that's why what happens, the earth emit radiations back to the space. But because of the greenhouse gases that is the presence of the greenhouse gases within the lower atmosphere that traps the heat, that doesn't allow the heat to escape from the atmosphere. That's why that remains in the atmosphere for the longer time. And because of that, our survival has possible. Okay. Now, only thing is that what happened, the amount of the greenhouse gases has increased. So that's why the more heating has happened. Okay. Okay. And one more thing is that land use land cover. Okay. So land use land cover is how we are using the land. Okay. So whether we are using for the urban area building, we are building houses, everything, or we are using for the agricultures. Okay. And land cover are basically the physical characteristics of the land, like whether it is forest, water body, or desert, or anything. So if you want to change the land use and land cover, so that comes like land use and land cover there. Okay. So we can change this through agriculture, we can change it through urbanization, which we can do the deforestation. And what will happen if we because of this deforestation or change in the land use land cover, so that reduce the carbon sequestration and alter albedo. Okay, the albedo is, if you don't know what is albedo, albedo is the reflectivity of any object. So the snow has the highest albedo, so highest reflectivity. Okay, if Earth has a certain sort of land use land cover, okay, and what happened due to the change in the land use land cover, so let's say the whole Earth was green at some point, okay, and because of green surface, the emission, the reflectivity is different than the. So if you consider any desert land, that will the reflectivity will be higher. If it is forestry, then the reflectivity will be less. Okay. So that's how that changes the dynamics of the atmosphere. Now let's come back to one more question. Okay. So if I ask you, which greenhouse gases do you think contribute the most to the global warming? Okay. Can you scan this code and just give a vote, whatever you think? Okay. Okay. Scan the code. Okay. Scan this code and you can vote now. So first option is carbon dioxide. Second option is methane, nitrous oxide, water vapor. Okay, these four options. Do you think which one is the most contribute to the global warming? Whatever you feel like. Okay. If you feel carbon dioxide, if you feel methane is the one. Okay. Just you have to vote. If it is 1, 2, 3, 4. Whichever you feel. We have four options. Are you getting any issue with scanning the code? Okay, carbon dioxide 1, very good. Anybody else? So carbon dioxide, methane also you get, that's also a pollutant. Nitrous oxide come from the vehicles, smoke. Water vapor is also sort of a, I can tell you how water vapor is a pollutant, is the greenhouse gases, because water vapor traps heat from the whatever comes from the atmosphere, from the surface. Okay, so that's also a, okay. Carbon dioxide is coming more. 4, very good. Any vote for methane? Because, well, methane, one of the methane gas, what happens? Methane gas is almost 25 to 30 times deadlier than carbon dioxide. Okay, so that has more global warming potential. What we call is global warming potential. Which gas has the more potential towards the global warming? That is called global warming potential. If you rate 1 for the carbon dioxide, then you can, that is 25 to 30 times deadlier than the carbon dioxide is the methane. Okay, so that's, and also the nitrous oxide, that is also equally dangerous, because that is almost 300 to 400 times deadlier than carbon dioxide. Okay, so that's how it is. Only 6 votes. Can we have more, please? We have 113 people. Can you have more? Any more? Five, 1, 6 only so far. Six, just 6. Any other? Any vote for methane or nitrous oxide? Or any more vote for the carbon dioxide then? Anyone? You can, all you can see there, right? My screen there. Just 6 vote. Please, few more. Now, shall I go back to the main presentation? Anybody? Any more vote to the poll? Your name is not visible, so you don't worry what you give. So just you have to scan and just click to one of the option. That's all you have to do. Okay, very good. This 6. Okay. Okay, let me tell you about, because all of you are faculties. This, if you have not used this Mentimeter, you can use in your class. Okay. So, and the presentation can be more interactive then. You can allow the students to participate in your class. So everybody has a smartphone, so they can do the poll or any kind of question you think of, and you just use this one. If you know, that's better. Already, if you are already using it, that's very good. But in case you are not using, you can use this one. Okay, let me get back to the presentation again. Okay, so the maximum vote came for you people think is the carbon dioxide. Okay. Yes, so you're absolutely right. The carbon dioxide is the gas which contribute most to the global warming. Okay. So the reason why, because of the evidence of the carbon dioxide in the atmosphere, it is almost 76%. Okay? 76% of the 76% of the global greenhouse gases. It's come from the carbon dioxide alone. Okay? And it is emitted by all the human activities, by burning the fossil fuel, coal, oil, or natural gas, deforestation, industrial processes. Okay, so, and the longevity of the carbon dioxide. So it can not, it can remain up to 100 to 1,000 years. While the other greenhouse gases, well, the lifetime of carbon dioxide about 30 to 40 years. But the cumulative impact of the other gases like methane, nitrous oxide, which have higher global warming potentials. Okay. So, but the carbon dioxide emitted in a much larger quantity, making it dominant driver of the global warming. So if we can compare the key greenhouse gases, so let me change. Okay, so the carbon dioxide, which accounts 76% of the greenhouse gases, but the methane has much higher global warming potential, which is 28 to 36 times that carbon dioxide over 100 period. But it is not that much in the atmosphere. Next is nitrous oxide, which has a global warming potential of 465 to 298 times of carbon dioxide. Okay, so but it is emitted in a lesser quantity. Yeah. So fluorinated gas, that is also extremely harmful, but it is in this small amount. Okay. So carbon dioxide is the primary target for mitigation efforts, such as now you might have heard about the carbon offset projects. Okay. How to net zero. That is all hover around carbon dioxide. So that's transitioning to renewable energy, improve energy efficiency, and reforestation. Okay, so so this is all about how the carbon people are targeting to reduce the carbon dioxide. Once they can reduce the carbon dioxide, everything else can be taken care of because that is not of that much amount. Okay, so reducing carbon dioxide emission to critical limit the global temperature to 1.5 degree or 2 degree as agreed on the Paris Agreement. So if you come across the COP 21, 22, 23, COP 29 recently happened uh, in Aberdeen, not Aberdeen, of course. Azerbaijan, sorry. Azerbaijan. Okay. So there is a panel called International Intergovernmental Panel on Climate Change. So whatever climate change happens on the globe, so there is a panel called IPCC. So that is a global body that assesses the science related to climate change. So it was established in 1988 by World Meteorological Organization and the United Nations. So both of them set together, they build a body called IPCC, and whatever related to the science related to the climate change, this panel take the all decision to the provide all the policies to the policymakers. So what they do regular assessment of the scientific basis of climate change and its potential impacts and the future risk. What are the future risks and what are the options we have for the adaptation and mitigations? Okay. So those are the, they do those things. So if you look at the timeline of this, IPCC FAR is the first assessment report. SAR second assessment report, TAR third, AR4 fourth assessment report, AR5 is fifth assessment report, and recently it was sixth assessment report. Okay, so that's how it has come across. The IPCC has developed its assessment reports. Okay, so in that period, what they gather all it takes about 5 to 6 years to work on one topic, the climate change throughout the globe, and it consists of all the scientific research center throughout the globe, almost more than 1,000 to 3,000 to 5,000 scientists work together to come up with one policy. That's called the first assessment report. Okay. So I was fortunate to be a reviewer of the AR6 adaptation plan. When I was in Singapore, I reviewed this one, AR6. So almost more than 5,000 scientists are author of that. Also around 1,000 scientists are review those reports. So I reviewed one. Yeah. So what is called, you might have heard about CMIPs. Not sure if you have, but if you have come across CMIP, what is CMIP is the coupled model intercomparison project. So what is its coupled model? So in order to, I think in prior presentation, you might have heard about the model, climate model, weather model, numerical weather model. Okay. So what happened in that model? If you want to do some kind of forecast, you have to do a model. You have an observation until now. If you want to make a forecast for tomorrow, day after tomorrow, you have to give some kind of initial data to that model. And that model will solve the physical equation in the atmosphere. And there are thousands of equation will be there because all the processes in the atmosphere are written as some code in the model. And that code will process your initial data. Initial data means if I want to make a forecast for tomorrow, I have to give the data till today. So like temperature, wind, humidity, okay, moistures, sea surface temperatures, soil moisture. So there are a number of variables we have to give them. So that if you know about momentum equation, ideal gas law equation, okay, okay. So equation of motion. all those equation is some way it is related to the atmospheric activities. So all those equation are solved using those codes. Okay. That's how a model is built. Okay. So it has, there are few types of model. That's atmospheric model. Another one is land surface model. Another one is oceanic model. Okay. There are vegetation models also there. But this coupled model, in that model, whatever, all these models are coupled to each other. So there will be ocean model, there will be atmospheric model, there will be land surface model. Okay, there will be a chemistry model. So all model will be coupled to give their output. Okay. So there are 6 phases already have been completed in the CMIP. First CMIP was in 2001, CMIP 1 and CMIP 2. Then CMIP 3 was done into 2007. So first CMIP, if you can look at CMIP 1, primarily focus on the atmospheric model and simple coupled ocean atmospheric model. So first there was different ocean model, there was different atmospheric model. So CMIP 1 coupled both two. So the ocean data goes into the first, the ocean model is run, and with that model the atmospheric model is run. Okay, from ocean model, the all kind of ocean current, ocean temperature, all that has been fed into the atmospheric model. Then atmospheric model run for 1 day. Then again 1 day that ocean model run. Then this is coupling happens each time steps. Okay, that is that has happened. First it was done in CMIP 1. Then comes the CMIP 3. So CMIP 3 introduced a wider range of models, including more complex ocean model, more complex land model. And in this, different scenarios were introduced, like that was called SRES scenarios. So in that scenario, that's called A1 scenario, B1 scenario, A1B scenario, A2 scenario, B2 scenario. Okay. So A1 scenario is business as usual. If you don't, whatever the way you are doing, if you keep doing like that, that is was A1 scenario. Okay. And B1 scenario, if you control everything, is a B1 scenario, and middle of the road A1B scenario. Okay. So if you do the development with energy efficient, that is okay, and that is middle of the road. Okay. Then with CMIP 5, a larger number of model was introduced, and with a model physics was also introduced, and number of broader range of simulation were done. It came with the 5th assessment report, and also they introduced a new emission scenario that is called RCP, so representative concentration pathway. So RCP 8.5, that if the radiative forcing is highest in RCP 8.5 and RCP 2.6 is the lowest. Like in first CMIP 1, I said, or CMIP 3, I said about A1 or business as usual. So RCP 8.5 was the business as usual. And the controlled scenario is the RCP 2.6, RCP 4.5, that has different scenario, like controlled development scenario. And latest one is the CMIP 6 scenario, CMIP 6 model. Again, the wider range of scenario, more focus on the regional climate information was fed into the model, and it comes with the SSP. Here, what happened, the socio-economic were included in the model. Okay, socioeconomic development and the climate change, those things were included in the model. So that is more realistic one. So SSP1, SSP2, SSP3, SSP4, SSP5. So 5 scenario there. Okay, so now you might have heard about what is the Paris Agreement. Okay. Okay. So what is the Paris Agreement? Why it is so important? So the Paris Agreement is a landmark intergovernmental treaty on the climate change, which was adopted by 196 countries in 2015 in Paris. Okay, so every year, United Nations do a conference called COP 21, 22. Now it's 29. Okay. So the key goal was to limit the global warming. Okay. So at that, after 2015, the new definition came. People were discussing about 1.5 degree scenario, 2 degree scenario above the pre-industrial level. So the agreement was to aim to keep the global average temperature rise below 2 degrees Celsius. And we need to make effort to limit the temperature is to increase even further 1.5 degree scenario. I will tell you in the next slide what exactly is global warming level, how it is calculated. And climate change adaptation, it seeks to increase the ability of the countries to so and some financial support was agreed. The agreement called for developed countries to provide financial resources to help developing countries to reduce their emission and adapt to climate change. Like UK, US, all the developed countries, they have already developed. They have already emitted enough carbon dioxide into the atmosphere. But as we are developing countries, if we stop all our industries, we will not be able to survive. So what happened? Because and all the if you will be surprised, most of the dress or any kind of things you will buy in UK, everything is either made in India, made in Bangladesh, made in Vietnam, or most of made in China. So all the industries, they are not. UK doesn't do any manufacture here. Everything they mostly import from other countries. So those are called some scope 1, scope 2, scope 3 emissions. So scope 1 is emission is if a industry like oil and gas industry, they emit directly. So that is called scope 1. Scope 2 is if I buy from the industry directly, I'm buying some coal or a natural gas. So that is scope 2. And the developed country, what they does, as I gave you example of the dresses or any kind of things, they buy from India. Okay. And for UK, India is increasing their greenhouse gases. Okay. So that is called scope 3. So now all the industries or everybody is worried about the scope 3 emissions. Okay. Okay. Now look at the right side, that global temperature change. So it's starting from 1850 till 2021. How the temperature increase. The inner circle is about 0 degree. outer circle is 1.5, middle circle is 1.5, it's 2 degrees. And how do we know that it is, what is the global warming level? The global warming level is compared to the pre-industrial. So pre-industrial normally we take about 1850 to 1870. After that, the industrialization happened. So now we are almost 1.5 degree as compared to the uh, mm, pre-industrial period. Okay, so you can see that temperature is almost into a 2021. This is not the updated chart. Okay. So the updated chart is almost in 2024, almost it crossed the 1.5 degrees in Celsius. Okay, so how do we model that? How do we see that this is 1.5 degree or 2 degree or 3 degree or 4 degree? So how it is calculated, let's say the whole globe is of 15 degree. It was 15 degree, the Earth's average temperature 15 degree in pre-industrial. And so that doesn't necessarily the every part of the world was 15 degree that time. Okay, some part like the tropical world is mostly 25 to 30 degree. Okay, the desert will be much warmer and the polar region will be much colder. So that average out the temperature. That's how the 15 degree came. So that 15 degree was during the pre-industrial period. That was, and as compared to that pre-industrial period, what is the temperature? It is now. So based on that, the temperature is 1.5 degree. We are almost crossed this last year. So it is almost 17.5 degree. We can say that. Okay. So now the thing is now, but different region have different temperature warming. Okay. Our India might have warm by 3 degree, 4 degree, and like Antarctica might have warm by 5 to 6 degree, and some other places might have uh, cooler by few degrees. Okay, so altogether, what happens if it is the average temperature? Because we compare with the different model have different dynamics, different model physics. So most of the model agrees that, and how it is calculated, let's say it is because it is not just 1 year, it is consecutive few years. It has to be now this year it has crossed 1.5 degree. If it will remain for another 5 year or 10 year, then we can consider this as a period of more than 1.5 degree. Okay. So if I want, let me go through this plot. If you see the left side, the start of 1 degree is about 1990 or later 1990s. Okay. And 1 degree, it's n means it's a bunch of the 50, 60 models. In one of the model, it's about 1990. In other model, it is about 1 degree is about 2015. Okay, that is that basically I'm trying to see, so the range of, okay. So in 1.5 degree also, some models, so from 2010 and some about 2023 to 25. Okay, it's like 2 degree. So similarly, those are the different global warming levels for the different climate models. Okay. Let's get back to what was the main motivation of the study, what I did here. Okay. So since we know, based on the different what I've said earlier. So we know that the Earth's surface has changed rapidly, okay, because of the coupling of the land surface and atmosphere. And our South Asia, because South Asia and Southeast Asia, this whole part has undergone a lots of changes. Okay, so this, if you see that this is land cover in pre-industrial period. The darker means more it is. It has more. It is there are dense forest and those things. Lighter means it's there is forest cover has reduced. Okay, so what happened as compared to the present? During the pre-industrial period, there was more. The forest was very dense. Also look at the greenhouse gases. Greenhouse gases, this is for the 7 countries of South Asia. Yeah. So if you can look at the India, the greenhouse gases or the carbon dioxide has increased significantly. Okay. Also, you can see that Myanmar and other countries, they're really Bhutan, they're negligible. Myanmar has also reduced uh, its greenhouse gas emission. So this changes in the land cover and greenhouse gases. Okay. So what it happens, there are 2 sources of moisture for any kind of rainfall. One moisture comes from the ocean, from the evaporation, and another source of moisture comes from the land, from the evapotranspiration from the forest or the trees. Okay, if there is more deforestation, that means the moisture is less available, local feedback is less available. Okay, so mostly dependent on the oceanic moisture. So that's why we can expect the drivers of change of precipitation or evapotranspiration feedback to these changes. Okay, so that's why it's really important to study the combined effect of the greenhouse gases and land use land cover. So what happens because of the land use land cover change, because of the deforestation, the moisture feedback from the land has reduced, so that essentially that will reduce the precipitation. Whereas the increase in greenhouse gases, what happens? Because of the greenhouse gases, they increase the temperature of the land. So if it is more increase, the increase in temperature, the water holding capacity of the air parcel will increase. So that can hold more air. So that can give you more rainfall. Okay. So some way or around, they acted differently. Okay. So that is the reason you might have heard about the cloud burst more frequently, more intense rainfall happening. You might not have seen in your childhood that let's say 20-25 years before, this much rainfall in 1 hour or 2 hour or few hours. Okay. That because of this greenhouse gases, the water holding capacity or specific heat capacity of the uh, air parcel have increased, and because of that, this much rain is happening. Okay. Now let's look at the detail level of the what are the different type of vegetation present. So broadleaf trees, C3 type grass, C4 type of grass. Okay. So again, the denser, if you look at the color bar, you can see that the color bar is the denser is the higher the percentage. So this is a fraction of land. So out of the one grid cell, how much is the fraction is the broadleaf trees. If you see the broadleaf trees, most places is close to 0.8 to 0.9 during pre-industrial period. Okay? And look at the Himalayas, Tibet, it is mostly C3 type grasses. C3 type grasses like any kind of grasses you can see, and C4 type of grasses are mostly uh, uh, the agriculture wheat or those type of wheat, rice, those. Okay. Now this is the present. Present means 10 years before. Okay. So the broadleaf trees, you can see that this massive reduction. That this one came up to almost 0.4 to 0.5. That much reduction happened in India. So I just highlighted few places like where the most deforestation happened: Central India, South China, Thailand, Indonesia. Okay, and all of this is mostly replaced by either C3 type grasses or C4 type grasses. The red color is decrease and blue color is increase. Almost 40 to 50% have reduced. Let's see in a better way here, in just focus zooming on to India. Okay, the greener is higher and denser forest. Okay, look at this. Look at it. This is almost 50% of the India, central and southern India has reduced its broadleaf trees. Broadleaf trees means big trees. Okay. And it is replaced by mostly the C3 type grasses. Okay. And let's see how it has changed decadally. So by each decade, starting from 1870 till now, how it has changed. Gradually, it has changed. Okay. And prior to our independence, it was okay, but after independence, it has reduced rapidly. You might have, I had highlighted few of the locations which says about the how much it has changed if we average over that region. So by year, almost it has for India, it is almost decreased by 41, 42%. South China almost 30%. Thailand bit less, but Indonesia also about 40%. That much broadleaf trees have reduced. Okay, what happened to the temperature, rainfall? Okay. Has it changed anything? So the blue is summer monsoon, our JJS period. Black is annual, and blue, green is winter precipitation. Okay. So there is no specific trend of the rainfall changes. So as I said earlier, in the first slide earlier, that what might have happened, that land use change has reduced rainfall, and global greenhouse gases increase in greenhouse increase the rainfall because of the water holding capacity. Okay, so is that the one what is compensating the land use change? So that's what I have studied in this work. Okay, so the objective, what is the objective with this? So we want to look at what are the change in land use land cover, how it has affected the rainfall, and investigate the greenhouse gas change on the rainfall. Whether how the land use land cover has affected rainfall, and how greenhouse gas change affected the rainfall. Okay. And examine the change in local evapotranspiration in the total precipitation. So local evapotranspiration is the evapotranspiration from the trees, forest, and the land. And because of the whether the moisture advection, moisture from the ocean, the sea, has increased because of the greenhouse gas change. Okay. So what we have done here, we have used a model called HADCM3. It's a model from the UK Met Office. Okay, Hadley Center Climate Model version 3. So if you can see the simulations, I carried out 3 simulations. In one simulation, first simulation, I fixed the greenhouse gas to pre-industrial level. And I fixed the land use land cover to pre-industrial level to 1870. So all the model simulation was carried out from 1870 to 2016 period of time. So almost 150 years, let's say. Okay, 146 years to be specific. And second simulation, I just fixed the greenhouse gases, but change the land use land cover to the observed as observed. Okay, to see what is the effect of land use land cover. Okay, then both land use land cover observed and both greenhouse gas both observed. So greenhouse gas observed and land use land cover also observed. Okay, in the model, one more thing I did, I introduced 2 hydrological tracers in the model. One tracer, what that does, that tracks the water evaporated. So when the rainfall happened, that tracks that water, where it is evaporated from, where is the source. Okay, so whether if it is evaporated from the ocean or it is evaporated from the land or transpired from the land. Okay, so one new tracer tag the water evaporated from the ocean and other tracer tag the water evaporated or transpired from the land. This is the first time this has been done. So what it happens, it will allow us to investigate the recycled, how much, what percentage of rainfall comes from the recycled precipitation under this different scenario. So how I have done, I have taken the difference between the simulations to study the impact. So land use land cover change impact, I have taken the land use land cover change, both observed simulation, land use land cover change simulation minus control simulation. Okay, so if you see that fixed greenhouse gases, greenhouse gases, observed land use land cover, fixed land use land cover. Where greenhouse gases, so land use land cover simulations plus greenhouse gas simulation minus land use land cover simulation. So observed land use land cover plus observed greenhouse gases. So this cancel out. So we can get the greenhouse gas impact. And what is the combined effect? So the control simulation by the observed simulation. Okay. Okay. Is it falling boring now? Initially, it seems like it was interesting. Now it seems like it is going towards more toward technical. Okay.
No, we are enjoying.
Okay. So what happens to the total precipitation? Because so as I said in the previous slide, I said how did I calculated the impact, okay, from different simulations. So if you top row is the only greenhouse gas change, middle row is land cover change, this is the combined change. Okay. So during our most of our rainfall we get from summer monsoon. So due to the greenhouse gas change, that has increased the rainfall.
Another. Shirin ma'am, your work is done.
Connection.
Check your net connection.
But it's not
log
showing,
out.
ma'am.
Ma'am.
Please check your connection and do it again.
Yes, ma'am. It's completely fine. If you want, I can share you online also, ma'am. There's
No,
the
don't
recording.
It's check it at your end only.
From our end, we have done, ma'am. Shirin ma'am. Teja ma'am, your work is done. Shirin
Yes,
ma'am,
ma'am.
your
Hello,
task
ma'am.
is done.
What
Yeah.
is
Yes,
my
ma'am.
work, ma'am? Pratibha Soni.
But why it's showing like this, ma'am? Should I? Because I have given the feedbacks for all the sessions also, ma'am. Then also like this, ma'am.
Shirin ma'am, from our end, we have completed your task. You check it at your end, please. Pratibha ma'am, have you texted it to Sonali ma'am?
Yes,
Pratibha
ma'am.
ma'am.
Yes, ma'am.
Pranati madam.
Pratibha Soni ma'am. Yeah.
Pranati
Pratibha
madam.
we are working on
Ma'am,
it.
can you share me the details, ma'am? Can you share me the details that you have uploaded, ma'am? Because it's showing absent only, ma'am.
Shirin ma'am, there are 15 to 20 queries. 40 queries. So
you people are saying that you have solved, na, ma'am.
Yeah,
But here, but
we
it's
are
not
there.
showing. I have
Shirin
10 times I have
ma'am.
logged out and I've refreshed with the ma'am.
Shirin ma'am, we are doing video call with you so that from our end we have resolved. We will show you that one. Okay.
Pranati madam,
Okay,
please
ma'am.
check for mine.
Yeah. Shirin ma'am, just wait patiently.
Yes,
We'll
ma'am.
do a video call from our end to showcase that we are
ma'am.
clear.
Okay, ma'am.
Pratibha ma'am.
Yes, ma'am.
Yeah. We are working on to it. Your query.
Okay, ma'am. Okay, no issues.
Yeah. Just have patience. In another
Okay,
few
ma'am, no
minutes,
issues.
as soon as all the queries are over, we'll start with the valedictory.
Okay, ma'am. Take your time.
Yeah. Thank you.
Madam. Yeah, Pranati madam. This is
Yes,
Manisha.
yes. Yes, Manisha.
I think what my message is not read. So that's why what I have.
Okay.
Yeah,
Done,
just wait,
Manisha ma'am.
Done?
Manisha Divte ma'am.
Manisha Divte ka? Babu ka?
Madam, good evening. This is Rajendra Padalkar.
Yes, sir. Rajendra sir. Yes, sir.
Yes, ma'am, actually, I have also sent the messages. I'm
whom?
waiting, ma'am. So,
To whom you have
when
sent?
the time permits, please do the favor, ma'am.
Yeah. To the coordinator, if you have sent it, just give us some time. There are 40 plus queries from all participants. We are into
right,
it.
ma'am.
We are in the queue.
Right,
Thank
ma'am.
you so
Okay,
much.
okay. Thank you very much.
Shirin ma'am, you can check it. It's resolved from our end.
Pranati madam. Hello.
Madam, good evening, madam.
Hello.
Yes, ma'am. Yeah.
Yeah, it's
Yes,
done.
Manisha ma'am.
Yeah. Thank you very much.
Thanks
It's
for
updated.
acknowledging. Thank you.
Yeah.
Yeah. Thank you, Pratibha ma'am, Manisha ma'am.
Vicharu.
Shirin ma'am, are you checking it?
Madam, good evening, madam.
Good evening. Yes, sir. Sunil Kumar, sir. K. Sunil.
Yes, sir. My name is Sunil Kumar. Sir, please update my attendance, sir. I attended all the sessions.
It's done from our end.
It's done from our end, sir.
Just log out, log in again and check it.
Okay,
Sunil
sir.
Kumar Sahu, right?
Yes, madam. My name is Sunil Kumar, madam.
Sir, Sunil Kumar Sahu, right?
Yes, madam.
It's done, sir.
Okay, thank you, sir.
It's done.
My issue is not resolved, but I have sent the
Venkatesh sir, you need to text it to our coordinator. That's what our last conversation was. Have you texted it?
Thank you, ma'am. My problem is solved.
Thank you, Priyadarshini ma'am, for acknowledgement. Venkatesh sir, to whom you have sent the message?
Sunil Kadam, sir.
Sonali Kadam ma'am. Yes. Venkatesh Mishra, Dr. Venkatesh Mishra. Yeah. So give us a few minutes, Venkatesh sir. We are working on it.
Venkatesh, sir, once again texted.
number.
Venkatesh sir, with your name and all details, na, text it to Anjali Kadam ma'am.
My number is
Huh? Okay, okay.
Please. Anjali Kadam, ma'am. Ma'am, I have sent again the details. Anjali Kadam.
Venkatesh sir, coordinator is working on the same, your case only. Just give us 1 minute. She is working on it.
Okay, thank you, ma'am. Thank you.
Ma'am, when will you start the assessment, ma'am?
8 p.m. Venkatesh sir, you can check your attendance. Test will start at 8 p.m. today. Before that, we have to wrap up these attendance issues and then we have to start with valedictory.
Okay, ma'am. Okay, ma'am.
Okay, ma'am.
Just
Thank you.
wait patiently. Yeah, Thank you, Venkatesh sir, for acknowledging. We are going to start with the valedictory in next few minutes. असं वाटतं ना असं.
प्रतिभा सोनी.
Good evening, everyone. I am honored to be here today to conduct the valedictory session for this esteemed faculty development program on navigating climate variability and impacts for effective water management, disaster preparedness, resilience, and mitigation. Over the past few days, we have delved deep into a topic that is of critical importance not just for us but for future generations, the intersection of climate change, water management, and disaster resilience. On behalf of Bharati Vidyapeeth College of Engineering for Women, Pune, I, Professor Pallavi Narkhede, express our heartfelt gratitude for the successful completion of faculty development program on navigating climate variability and impacts for effective water management, disaster preparedness, resilience, and mitigation. I would like to express my deepest gratitude to all the resource persons, facilitators, and participants who have made this program a success. Your active involvement, thoughtful questions, and insightful contributions have made this FTB truly special. I would like to take a moment to express my heartfelt gratitude to the coordinators, Dr. Sonali Kadam and Dr. Ashwini Ranade, and organizers of this faculty development program. Your hard work, dedication, and meticulous planning have been the backbone of this event. From conceptualizing the program to ensuring everything ran smoothly, you have truly gone above and beyond to make this session a success. Our heartfelt thanks goes to our principal, Dr. P.V. Zadav, for his leadership and vision in fostering an environment where events like this are made possible. We are also grateful to the vice principals, HODs, and all faculty members for their supports and encouragement. My heartfelt thanks goes to the non-teaching staff for their behind-the-scenes effort in making the event run smoothly. In conclusion, I would like to say a big thank you to each and every one of you who contributed in making this FDP a success. Let's continue to work towards a future where climate change impacts are not something we fear, but challenges we are well prepared to face with resilience and innovation. Thank you. Thank you so much. Ashwini ma'am. Dr. Ashwini Ranade ma'am.
Hello.
Ashwini ma'am, I request you to please share your reviews.
Yes, yes. Thank you so much, ma'am. Dr. Anjali madam and my dear participants. So on the behalf of NIH, I again extend my welcome to you all for this today's farewell function of our 6 days online training course under ATAL FDP program. So as you all know that so far we have conducted 13 sessions back to back on this topic, different topics of weather and climate, and then climate mitigation, climate modeling, climate adaptation, different flood monitoring techniques, disaster management, and today we have seen land use, land cover changes under climate change, and also we covered the research methodology as well. So I think overall we have tried our best to cover most of the topics in this course, and by taking consideration of the society's need and different sectors which can affect our country's economy as well as growth of the nation also. So we are very much happy and delighted to all of you to us in this 6 days journey, and also we appreciate your presence in each and every session, your participation, your attentiveness, and your curiosity to understand each and every even new topics as well. So, and I can say that it has been clearly reflected after each session during the interaction with speaker. You all have participated very interestingly. So, thank you so much for your this keen interest for throughout this course. And as I said, that also there is always a scope to improve. So, we really need to know from your feedback forms or which you have submitted, and also which you will going to share today with us here in this validatory session, so that we can improve ourselves in our next coming sessions, our coming training course. So I hope that after completion of this course, you have carried something with you, so which you can use in your future endeavors, in your research or teaching. So again, thank you so much for your presence. And I also would like to thank Bharati Vidyapeeth College of Engineering for Women Pune for making us part of this course, our important training, I can say important and prestigious training course. So for NIH also, this is really a new experience as well. And why I am saying, because many speakers which have delivered the talk in last week, they have given their feedback also, and they were all saying that all the participants are very much interested and very much enthusiastic for interacting with the speakers, and they have really raised a very good questions. So that indicates your interest in this subject. So once again, thank you for this participation, and again, thank you, Bharati Vidyapeeth, and thank you so much, everybody. And ma'am, over to you.
Thank you so much, ma'am, for sharing your thoughts.
Thank you.
Now I request Dr. Sonali Kadam ma'am to express her thoughts with us.
Thank you, Ashwini ma'am, for your briefing. There is one more announcement to do, that there is one Google form will be shared immediately after this, related to the reflection journal. I request all the participants to fill this Google form of reflection journal. It is about what outcome of this FDP, what takeaway you have taken from this FDP. And as per the ATAL format, we have to submit this reflection journal format also with with the participants' name. So before 8 p.m., I request everybody to submit that Google form. Within a 5 minutes, we'll share that Google form. The Google form will share on a WhatsApp group.
Okay, thank you, Sonali ma'am. Now I request to the participants, please share your thoughts.
Hello, good evening. Hello, am I audible?
Yes, sir. Yes, sir. You are audible. Yes, sir.
Yes. My name is Nitin Savarkar. I am actually here to give the feedback of the faculty development program, which was attended by me. The theme of this program is navigating climate variability and impacts of this climate change on the various parameters on the environmental engineering, on water management, on how we can have the preparation for the disasters to be get happened in future due to this climate change. What are the various mitigation measures which are proposed by interpanel government on climate change, that is IPCC. Um, every year or 2 year, the IPCC is publishing the reports on climate change, and through this FDP, we came to know that what are the various mitigation measures has been undertaken by these various committees. So this is one of the most important takeaway from this particular FDP. I sincerely thanks the National Institute of Hydraulics NIH for this association with Bharati Vidyapit for this organization. And also, I'm really thankful to the organizers of Bharati Vidyapit for this smoothly conduction of this FDP. Through this FDP, the important takeaways are nothing but the differentiation in between climate and weather. We came to know what is the climate, what is the weather, what are the weather prediction means, what is the climate, and what are the various forecasting methods which are generally available so that we can easily have the prediction. Some of the speakers have had the thought on climate variability and climate change. Some of the researchers has had the thought on effect of this climate change on the climate change due to the greenhouse gases emission, and that has happened for last few decades. The emission in the emission car is having the effect not only on the present situation, but it is also having the effect in the future. We had the CMIP5, we had the CMIP6. What is that? That also came to know us. We had the outcome of this FDP in the form of water management to be get done under the heading of climate change. Then there are some of the situations in which this climate change is adopted, and that is very, very much important parameter under consideration. I really thank Bharati Vidyapit for this arrangement of such kind of FDPs, and surely in future we are definitely going to attend this kind of. Thank you so much. Over to you, ma'am. Hello.
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 Am I audible?
Yes. Over to.
Yes. Thank you so much, sir, for sharing with us. Now I request Dr. S.R. Patil sir, please express your thoughts with us.
Yes. So good evening, one and all. Myself, Professor Dr. Sandeep Patil from Bharati Vidyapeeth's College of Engineering. So, first of all, I would say that the topic of this FDP was together each and every that is belong to the thrust area, energy, sustainability, and climate, which is a universal relevance to the. So I must appreciate the selection of the topic, which is relevant to every human being and every living species. So that is very important. Secondly, I would like to mention all the sessions were insightful, informative, thought provoking, and all the sessions were quality sessions. All the speakers and contents have enriched all of us through the topics and their presentations and research outcomes. It is indeed great to hear all the resource persons who belongs to research area, almost all of them were scientists, research scientists in their respective field, and they have presented their research outcomes on the given topic. This FDP, which is really all of us. The 6 days journey opened with the first session by Dr. Ashwini Ranade madam, which was very interesting. And we have many valuable sessions from all the scientists and researchers, just to name Dr. Vishal, Dr. Sunil, Dr. Akshay, Dr. Surjit, Dr. Vishal, Dr. Vijaya Pawar, Dr. Pawar, and we also have two resource speakers, very eminent personalities, belongs to international also from Cyprus University, and the last sessions which we had from Dr. Kanu Charan from University of Leeds, UK. So indeed, all the speakers have covered the insights and presented very well, which made this FDP very useful to all the participants. So I extend my sincere thanks to AICTE ATAL FDP for providing us the opportunity to attend this FDP free of cost and with on such a topic wherein we have been enlightened with a different aspect of domain which we generally do not used to be. Also extend my sincere thanks to all the speakers, mostly of them from National Institute of Hydrology, Roorkee, Dr. Ashwini Madam and all the team members, and also from other universities. So with there, because of them, this FTP was really wonderful and beneficial to all of us. I would like to congratulate the principal and the coordinating team of Bharati Vidyapeeth's College of Engineering for Women Pune for successfully organizing this FDP on such a topic. The coordination was fantastic. Just to name a few, Dr. Sonali Kadam, Dr. Pranoti Kaya madam, Anjali Kadam madam, all the team members from our computer engineering department, all the supporting staff directly, all of them deserve a round of applause for their fantastic coordination and organization. The takeaway of this FDP is that even though we belongs to most of us belongs to engineering faculty and streams, so we are disciplined basically to computer IT and TC mechanical civil, but we came to know that environment is above all. The environment, ecology, sustainability are above. So we have to come out of our disciplines and work for this multidisciplinary objectives to work together in a multidisciplinary mode and address the real world challenges towards the environment, ecology, and sustainability, which is directly relevant to our survival of human beings and all living species. So I think that is the great takeaway, spreading awareness about environment, ecology, and sustainability. So once again, I congratulate each one of you for this wonderful FDP, and thank you one and all. Over to you, madam.
Thank you so much, sir. Thank you so much, sir. We appreciate the time you took to share your feedback.
We share all participants to fill the link which is shared on a chat box. It is related to reflection journal.
Hello, ma'am. Can I give my feedback?
Yes, ma'am.
Am I audible?
Yes,
Yes,
yes.
Okay, clearly audible. Is there any noise?
No, ma'am. You are clearly audible.
Okay, thank you, ma'am. Good evening, all. I, Professor Suvarna Sorge, would like to express my own experience of participating in this faculty development program on navigating climate variation and impacts for effective water management, disaster preparedness, resilience, and mitigation, which is organized during 20th January to 3rd of February 2025. Please allow me for my exhaustive feedback device. All the sessions held were very informative, and all the speakers were able to deliver their contents to the participants very effectively. On the first day of the FDP, Dr. Ashwini Ranade ma'am and Dr. Sunil made us really think on why climate change study is important and its large impact. Second day, Akshay Verma sir and Dr. Kuldeep Sharma sir helped us to understand global warming and technological interventions in weather and climatic modeling. Third day, Dr. Surjit Singh and Dr. Ravi Kale sir, with their case studies, explain assessment of water availability and its quality and flood monitoring respectively very nicely. Fourth day, Dr. Vishal Singh and Dr. Vijay Kanaude enlightened topics like mitigation and adaptation strategies and atmospheric aerosols. I personally got valuable input for my research in the respective area. Thank you, speakers and organizers. Fifth day, Dr. Vijaya Pawar ma'am guided all the researchers to follow organized research work and encash it in terms of publications and professional goals. Dr. Yamini Pawar, with her case studies, presented made all the participants to look towards carbon footprints of the climate change as a new domain of research. Then on the last day in the afternoon, we had understood importance of drone technology by Professor Dr. Prashant Pawar sir. Dr. Sheikh Babar sir explained mitigation of all the natural disasters, as we know that natural disasters cannot be avoided but can only be mitigated for its impact. With his vast experience in the field of ecological resilience, we participants from engineering background could understand these methods and can spread awareness amongst all others. Last session on green house gas emission by Dr. Patnaik sir was very interactive. He gave us input for the interactive classes as well, like how to pose the question, how to get the answers from the students, and they should be interactive in the class. This was amazing. I'm delighted with by attending this particular online FDP organized by Bharati Vidyapit's College of Engineering for Women Pune. I'm really thankful for their efforts in giving us very thoughtful and very informative sessions by all the speakers. Special thanks to organizing principal, college principal and Dr. Coordinator Professor Dr. Sonali Kadam ma'am and her entire team. Very well organized FDP. Thank you all for your efforts and your inputs. Finally, I would say take care of nature. Nature will always take care of you. So this is the only lesson which we should understand as a layman and as a professional person. And we should take care of our environment for its sustainability. Thank you for giving us such a nice sessions and information, because we didn't understood rather what is the need of this topic. But now when we have attended it, we really understand the importance of it. Thank you very much, all, one and all. Thank you for giving me this opportunity.
Thank you so much, ma'am, for taking the time to provide detailed feedback on our FDP. Thank you so much.
All participants are requested to fill up the reflection journal Google form. So there are two things which are left. One is reflection journal ka Google form, which just now coordinator have posted it. All are requested to fill up that form ASAP, so that yeah, before test, so that only test is left, which will be activated at 8 p.m. today. So again, a gentle reminder to fill up the Google form, which is posted by our coordinator, Dr. Sonali Kadam ma'am, recently, which is about reflection journal. There are hardly 7-8 pointers which you need to fill up. Yeah. So this reflection journal, please fill up the form. And we request
the participants, please feel free to share the feedback with us.
Hello, excuse me, ma'am. Sonali ma'am.
Hello, ma'am.
Sonali ma'am. There is one request. Can we have a group photograph by switching on all the camera from all the participants? Can we have one group photograph?
Yes, ma'am. All participants are requested to turn on the camera so that we can have a group photograph. All participants are requested to turn on the cameras. Thank you so much for your wonderful response. We'll have few snaps.
Thank you so much, everybody, for your response.
Thank you so much, audience. Yeah, maybe another 1 minute. Yeah, thank you all. If there is any feedback which is you want to share with us, we will be more than happy. We are sure that the reflection journal Google form is filled by each and every one. Last reminder, the reflection journal Google form is filled by each and everyone. This need to be uploaded on ATAL portal. So please make sure that everyone has filled the Google form, which is recently posted by our coordinator, Dr. Sonali Kadam, about reflection journal. There are hardly 7 to 8 questions. Thank you so much, everyone. You are being a very amazing audience throughout all last
days it. And now herewith at 8 p.m. the test link will be activated. Based on your schedule, you can appear for the test ASAP. With this, on behalf of